think it is starting. Okay. Okay, so good afternoon, everyone. This is the last and fifth day for this STC. STC is about to provide you the hands-on training on software tools and techniques for scientific publications. Mainly in terms of software, we are learning root, GNU plotting, and GeoGebra. GNU plotting and GeoGebra will be covered today, and LaTeX, which you have been already introduced. So yesterday we discussed this root, the tree, how to create the tree, and what is tree about. Okay, we can, in short, I must say, we can save the variable in the tree when we are handling huge number of data, when we want to store huge number of experimental data, which is continuing, let's say, to 10 days data or 12 days data regularly. So in the millions of events, we have to store the momentum, the charge, the current, the voltage, and it is always useful to save the data in tree in a file. Okay, so I introduce you how to create a tree. I hope you can see a complete slide. This is the file which he introduced you yesterday. This is the tree, which always first name stands for the name of the tree and the title of the tree. And these are the branches of the tree. So let's say if you want to save one variable, store one variable, there is a branch one. This is the name of the variable which you want. Okay, and ampersand branch one meaning this is the address of the variable which will ask to save. And what is the type of the variable which you want to save? If there is a current, then current, or if there is a voltage, then those should be in terms of float or double. Okay, if you are storing, let's say, number of events, then it should be integer. You have to write the tree first, like you wrote the histogram yesterday, and the file always should be closed at the end of your program. Okay, now I am on the slide number 62, where I would give you a hands-on training on how to create a tree. Okay, now can you go to the so I'll explain you. So what this program is saying, let's open your exercise, the script. I am on the inside the exercise number 10. Can you see? Okay, there you just find ren.c. The Ubuntu user can use their terminal. Okay, and Windows user can directly either use the cmd command to get the terminal kind of things, or you can directly use the folder configurations. So can you see this script which I am displaying on your screen? So this says that I am creating a file, recreate, meaning I am creating a new file here. I am creating a tree here. There are two variables I have defined, which are type of float, px and py. There is a new variable integer, ev. Then the t is the object, pointer object for the tree. And this is saving px, address of the px, and the type of the px. Px is the momentum in x direction of any variable which you want to store. Then the same thing for momentum in y direction and the events. What do you mean by events? Let's say if you are doing some experiment where you are switching on some, let's say, beam. Okay, if you are a material science student or solid state physics and you are participating your experiment in IUSC or RR-Kit where the beams are available, the beam is switched. Let's say the beam is of electron beam, and you are hitting the beam on your some target. The target is your device which you want to irradiate it with the electron beam or photon beam, whatever you want. So that, let's say the beam is hitting on the this device which you have prepared, and you want that every event, let's say when you have switched on your beam, this will be your run on. every event is stored in this tree. So that event is how many hits or how many times they interacted with the bean. So we are making a for loop because we have to, we don't have data right now, but we have to do this exercise here. So what we are doing here, we are creating a for loop of, let's say, 100 and 1000 events, and we are storing px, py, ev, and we are generating them first using the random number. So these random number are divisible by 1000. You can use any class of the root for the event generation, whether it is a lender or runner, which we used last time. These are the predefined classes and functions in the root. Okay, and we are filling the tree object. So filling is always inside the for loop, writing is always outside the for loop, and closing is also outside the for loop, and this curly bracket is your function. Okay, main class. Okay, so now I am just keeping here, and just I am now working on the terminal. So what it will give it to you, it should create a root file which you are expecting with the name of ren.root, and you should see the tree. What is tree? I'll tell you. So can you please compile your program with me, root -l, inside the same folder, exercise number 10. Okay, .x, then your file is ren1.c, compile it. It will not display you anything, but when you make a .q, you are inside that same folder where earlier you don't have any file, the root file. Now you can see here the root file is there. Can you see this? Okay, how I can open it? I can open through the root browser. So root -l, T browser, any letter from your keyboard, and can you see this? Yes, I can see this. I am inside the exercise number 10, and there is a one script sitting, and this is the file which I have created. And there is now I can make it as a big. Can you see this? When I double click on the ren.root, which is the output file I created, there is a tree. And when I double click on this tree, I have 3 branches. Now I am showing you in your code what we did in the code. Can you see parallelly this code along with this on your screen? Can you confirm, Chanchal? Okay.
Yes, ma'am.
Okay.
Yes, ma'am.
Okay. So here, this is the px, this is the py, and these are the 3 variables which are double, and one is the integer. So you can see the leaves can be shown here. Now, if I'm clicking on one, now I will minimize this. If I click on the px, can you see? This is the randomly generated px. This is, I can keep anywhere. This is the number of events I generated. Okay, this is the px. These are the one-dimensional, you must say, variable. And when I click on the px, it gives me the histograms. But these are the variables. You can change this, zoom it, again, unzoom it. Okay, make also, yesterday I didn't show you log y, you can also plot. Okay, so you just see decimal, log y. Can I show you the logarithmic plot? Draw panel, right click, draw panel. When you click here, right, when you click here, maybe I should minimize it. Okay, when you click on the axis, there is, you can see it will change. And then again, if you don't do any operation, it will automatically. So here you can see set log y. So you can see 10⁻3. You can jump. You just see. Okay, this is on y-axis on logarithmic. I want to change this though. So you just click on, unlog it, and then there is a y-axis again 12 till going to 1200. I can squeeze it. Is that okay? Please do it with. I am now closing. How I opened it? I'm inside the exercise number 10. Root -l, T browser, space, some letter L or R, then colon. Then you will see a root file inside that folder, ren.root, and then double click. You will see tree. Then double click. I have already made it here. Then you have a 3 variable, 2 are of type float, 1 is of type integer, and then you have a plot. So if you don't know, here is the description and the how to compile is written for you. If you again visit those slides, let's say after a few days, and you can yourself understand if you forgot something, how to proceed to the next. Okay, are you compiling together with me this exercise number 10? Can you confirm if you are able to compile it? Please compile it together. Chitranchi say yes. Every student should say very good. Shreyansh, Meher, all student please. Those are window user and those who are, yes, very good. So at least you are getting familiar with how to compile it. Okay, sometimes it takes time to understand the language. So it will always take time. Don't worry for that, right? Just you learn, okay? C++ is just required to understand. Otherwise, we are just using those classes. There is no problem, okay? Now you just please compile exercise number 10. Now I am on the exercise number 11. Okay, I am in the exercise number 11. So as I given you one example yesterday, that if I am sitting at one other place and you and me only have an option to communicate remotely, like nowadays, I want to see your results and I want to analyze further, because I know you are a very beginner student. You took the experiment, stored your data in some root file in terms of branches or in terms of leaves. Those are variable, those are not directly histograms, so I can analyze that in further. If I want to change the binning, if I want to plot some two-dimensional histogram, see some dependency. So what I will do, I will ask you, please send me the root file which you have, and what I will do, I will read those root file and analyze those root file, because I am expert. Okay, so what in terms of collaboration we can do, if you are going somewhere where the experimental facility is there, you are taking the data, storing in the root file, give that root file to me where I am the expert, and then I will read those root file. I should know how to read those root file, and I should also know that I should have root installed in my system. Okay, so let's say I am the end user and I am also an expert, so I am reading those root file. Because you already created the root file, the data is there. Now I want to further analyze. What do you mean by further analyze? You have to you want to see some changes with respect to some variable. So you have to work. Okay. So what I am doing in my exercise number 11, can you go into the exercise number 11, please now? If you are done with the compilation of exercise number 10. So here I am in the exercise number 11 folder, and I am just always at least try to open that code with ampersand. The ampersand will give me the possibility to see this terminal along with the script. Please write your notes from the first day I am telling you, okay? So what this file says, and also please compare exercise number 10, which was how to create the root file, and exercise number 11, which is how to read those files. So there is can you see, maybe I can open both the code for you. Here it is, very nice. Can you see the Chanchal screen, and just confirm me if you see both the codes together?
Yes, ma'am.
Okay, so here you can see, the left hand side where I am creating the root file. This is you are working, let's say, some experimental site, and you have stored the data using T branch. Here I am the expert. I have sent it to you from the experimental site, and because I was unable to go there, I have a teaching responsibility. So you took the data, you stored the data, and I want to analyze that here. Okay, So what I will do, I will use this command. What is this command? This command says that now I am setting the branches to read those variable which you saved while taking the experiment. Is that okay? I said that you create those branches. I am setting those branches to read those variable. That is the difference. The creating branches takes 3 variable. Setting the branches and reading the branches doesn't bother that these are, I have to define it float. Already we have defined here. And just it is asking the name of the variable and the address of the variable. Just you have to make sure and remember as a beginner that you have to create the tree while taking the experiment, while taking the calculation, and store the data in terms of zip form in a file in terms of tree and branches, and utilize that in further analysis. If you are a beginner and don't know how to read that, you just sit with your supervisor and read those and analyze and learn how to analyze. What do you mean by analysis? Okay, the analysis is the process where you are selecting, make some selection and get what the result you want. Try to remove the background as possible, as much as possible. Okay, again, now I want to analyze and see the results in terms of histogram. So I have defined a new histogram here, HPX, new histogram, another HPY, made some loop on the end entries. These end entries was the same which I stored here. Can you see this 100 and 1000? It will read from the tree. So what it says, I am taking an integer and entries. This T was the tree and it will give me the get entries. Get entry is itself a build function in the root. It is just taking the number of entries from that tree which you are getting from a file, existing file. Okay, and then I am making over the loop on the n entries. Just I am getting this T get entry will give me all the variable, and just I am filling here. I am not doing anything else. This is just an example how to read. Then you do further your analysis, whatever you want. Okay. If these are the variable temperature, you just make some selection on the temperature, which window of temperature I want. And then check the other variable, the current as a, let's say Py is the current. So you just plot the current as a function of voltage. So let's say if 3 variable are Px is your temperature, which you change during your experiment, and you want now to see the result between temperature, let's say 0 to 100 degrees Celsius. So you will do some analysis here while you are offline. It is not required while taking the experiment, you have to analyze those data. Okay. So now I am closing the exercise number 10. If you have any question on understanding or comparing the 10 and 11, please let me know now. I can also explain you maybe if like the way you want, or maybe there is a confusion on how to create and how to read. So I am inside the exercise number 11 now. This is my script. This is the terminal. Now I am trying to compile it and see that whether I am observing those, visualizing those HPX and HPY. So here, this is the browser I am opening in my script as well. Okay. So let me check root -L. Okay. And then T browser L. So let's say those 2 histograms should be, I'm not writing it, but let me check where I am. Okay. So this is the, okay, so you can read those. You are reading those. This is the same. Oh, this is the same file. I think root file is showing me. Just let me. It is. Okay. This is .x. I am inside the exercise number 11. Okay, so I have to compile it. Okay. So compile it. Yeah, can you see this? Now HPX and HPY, you are reading this the histogram. Okay, so what was the HPX? This, and these are the same number of events which you created or took the while the experiments. Okay, can you see this? Then there is a HPY. Please understand what is the, so I know everything you cannot understand in one lecture, but you should know what it is at least, where to use it and how to implement it in terms of coding. Okay, so now I am closing this exercise number 11. Please compile this exercise number 11 together with me and let me know if you are able to see those histograms in the root file. Can you please confirm all to me that you are able to compile those exercise number 11 and reading the root file? Yes, ma'am. Okay. Please confirm so that I should know you all are awake, not sleeping. Okay. I know you had done a very hard work during these 5 days, but it is fine. We are also enjoying. Okay. And then we will take rest today and tomorrow. So please confirm if you are able to compile. Okay, so should I move to the next page and show you the important point, what you can see from the root tree and the root files? So here I am on the slide number 64, right? So this tree will give you different beautiful things, which is a print. It will show you what you have stored while taking the experiment. It will scan what are the variable is already stored in your experiment. You can draw a tree directly. Okay, you can analyze on the terminal. These are, let's say x is the variable and y is the other variable, and you want to see x while y is greater than 0. So to do some kind of analysis, you can print scan the tree. This is a beauty of tree. So this is a printing statement. Can you see? So what it says, I have opened this root file. It has some tree with a name T. I am taking T is my object of the pointer object of my tree. So it is printing what it is printing, how many events, how many events in an experiment has been taken. What is the compression factor, meaning it is a kind of zip folder. What is the size? It can handle huge size of the file and it will not take too much space in your disk. Okay, so these are different the baskets in terms of file size, different trees. Okay, and now I am on the slide number 66 where I'm scanning the tree. The scanning tree will give me the information of the variable which I have stored. Okay, now I am moving to the slide number 67, which is a very good thing I have kept for you. If you have a data in n number of root files, let's say 5 root files you have, and you want to say, I ask you, please share me only single file. Don't send me 4 root file. So how will you add? So there is a command for you, hadd. Set your, this is the command you can type on the terminal. Okay. And then you use this command hadd, then set your name of the output file which you want with extension .root, and you have these experiment 1, experiment 2, experiment 3, and then you are adding it, and output file will be this, and then you send it to me. Then I will read it and analyze it. You understood what I said? This 67 slides will introduce you. If you want to add the root file, how can you do on the terminal? If you have 5 or 3 root file, you use this command on the terminal. Hadd, set your final output file name with extension root, and then keep your file 1, file 2, file 3, and put an enter. Then you will see this root file will be automatically created in the same folder where you want to add those 3 files. Okay. So this is, we are done with the root, I hope. And now I will show you this hadd was the terminal command. But if you want to do it in a script, there is a beautiful thing, tchain is available. Tchain you can use in a scripting. So tchain will add file 1, file 2, file 3. If you want to, if you are dealing with the and adding, want to add all those root file which you have, and you can similar at the same time you can draw the variable which you have in that root file automatically in the script or also in the terminal. Okay, so more applications, please be connected. I'm showing you few things. If you have, there is a very good beautiful thing in the root fit. I introduce you about the Gaussian, right, fitting, which we took it yesterday from the fit panel, if you remember. If you don't remember, please visit to the previous slides. So there is a, let's say this is the example of the particle physics I kept here. What it is a one-dimensional histogram. Is it graph or it is one-dimensional histogram? I don't understand it. Can you tell me? Can anyone tell me what it is which I am showing here? Is it graph or is it one-dimensional histogram? Any student, all are welcome to contribute. Histogram. Chitranshi says histogram. Are you all agree with the histogram? Pragya also confirming that histogram. Fatima is also saying histogram. Very nice. Muhammad, very nice. Ankita is also saying histogram. How do you know that? Very good. It means you are working, right? You are working on those exercises, or you are compiling all those exercises which I have given to you. Yes, this is histogram. Okay, so this is a histogram. On x-axis you have produced some mass of some particle. This is a signal which I want to see, and this is the polynomial kind of background. Very nice. I appreciate. And this is the tpy class which is available in the root. So it is not only that the root you can see only one-dimensional, two-dimensional. What will be the application? Pie chart is a very good thing. You can just use on the terminal command. If you don't know scripting of the pie chart, you just see this kind of plot where we will use. Can anyone tell me where I can use these plots in real world? Can any other student tell me where I can use this pie chart in real world? Real world bole to? In your institution, in your daily work. Can anyone give me the example? I'll not move to the next. In cricket, very good. So Meher, in cricket, what we will show there? I don't understand cricket. Why you have cricket? I understood your point. Can Meher you speak and tell in cricket how you will show? What you want to show in the cricket? Okay, any other student? Meher, please explain us. What is the logic? Showing active recorded case of COVID. Very good. Pragya, very nice. Always COVID is there in your mind. Runs code in the particular direction. Very good, Vikas. And showing how much percentage of the students are taking different subjects. Very good. Very good. So we can show that, okay, this kind of, and the institution category also, we can show the area also where the rain is not there. Okay, the area which has water is where water is not there. These are the slice histogram, I must say. Okay, so very nice. That kind of logic you should know where to use that, and you should directly use the definition of this in terminal command. You can plot it. You change your name, slice 1, slice 2, and these are the representation which I show you yesterday. What is known as in a root? Can anyone tell me? This part. Can any student tell me this square bracket where I have shown the different color of slice 1, slice 2? What this known in a root? Please participate. Very nice. Mila, very good. Very nice. I'm very happy. So I want to know, Vikas, Meher, Mila, Fatima, are you all student of Which branch? Yes, Fatima, it is correct answer. Which branch? Can I know? Physics? I know you all are physics. Environmental science, Mila, very good. And Vikas? Mechanical engineering, very nice. You are doing very good job. And other students are engineering, physics, Shilpa, very good. I must say, my very nice. Yes, yes. I'm very happy that okay, you people are able to understand where I will. This I want. Okay, this I want from your side, so that you just know. I know no one will go to the manual and read this, but if I highlight you and interact with you, maybe you remember and use those facilities which we have as an open source available for your studies. This is the second application, TH2D poly plot. This is the two-dimensional with high precision D plot where I can use this. So it is already written, but you just tell me. This is Euro normalized to the surface area. It is shown. This is the histogram, and this is available as a tutorial part th2 poly.c class. It is showing something the longitude and the latitude of Europe parts. Okay, so we can also use that by showing our studies. Okay, very good. Now I am showing you the COVID-19 case which you have everywhere in your mind. So you just see what is that. This is in reality in August is plotted, and I took it from the Facebook page where one of our collaborated has shown his study in August month, maybe in August or early August. So you just see this is a graph or this is a histogram. Now you tell. This is a graph. I am on the slide number 73. Can you tell me? This is, of course, this is a prediction of the future COVID-19 cases in India. So you just say July, and then it was in August, and now we are in September. So it is just, or I think in March they have produced and that they predicting. So can you tell me what this is, histogram or this is graph? Kaz is asking, can use to show the incidence of COVID-19 graph? This is a graph, very nice. So because what you want to ask, you have a question on this plot or earlier? Can use this to show the incidence of COVID-19 geographically? I think earlier, yes. Yeah, this is graph. Earlier on the, yes, why not? Before the poly which I was showing you, this Vikas has a question. Yes, you can, but you have the data. You should have the data. So how you will compile this? This is again a graph, but with the grids. This graph and this graph is, what is the difference? This graph doesn't have the grids. This doesn't have the grids, and this has the grids. So grids means this. Okay, so Vikas wants to plot this. Yes, you can, but you should have the data. How to read the data, Vikas? You just put all those data in your text file or in your DAT file behind or in the same folder, and you can plot it in a very easy way. You just, what you can do, take the data your own, some numbers in your text file, keep it in the same folder, read those data using the C++ command, compile it in a root. Okay, do you understand, Vikas, what I am suggesting? How I can differentiate histogram and a graph? Okay, Mihir is asking. Okay, so okay, I am not getting this point. Okay, yes, Mihir is asking, how can I differentiate histogram and a graph? Can any student explain this answer? Can anyone of you participate? Yes, because just wait. We will come to your this thing. Can anyone tell me the answer of Mihir? That by seeing from his eye, he is unable to distinguish what is graph and what is a histogram. Anyone, please unmute your microphone. Don't waste your time and speak. Please speak. Okay. Any student who wants to give the answer? It is said. Yes, Chitranji, you can give.
Ma'am, mainly histogram can have many functions which are like not discrete
Mm-hmm.
in a continuous pattern.
Mm-hmm.
Whereas in graph we can plot in discrete way, like adding each and equal entries at a different level.
Mm-hmm. और सिंपल लेमैन को कैसे समझाएंगे? इफ मिहिर इज नॉट द स्टूडेंट ऑफ, और मे बी मिहिर skip or late join, so how I can convince him? Any other student want to participate, please? Okay, Mihiर, just graph as a smooth curve. Shilpa is saying, Mihir, can you think what, forget about the histogram for time being. Can you think what is the graph? Can you think what should I have that I can plot the graph? Can Mihir please unmute your microphone and give me the answer so that we can clear your, yes.
Graphical representation of data.
This is Vikas or this is Mihir?
Ma'am, Mihir.
Okay, graphical representation of the data is itself histogram also. I'm saying what you...
May I, ma'am?
Statistical distribution,
actually,
yes. You just...
Yes, sir. Actually, when we want to know the distribution of the data, then we use the histogram. Otherwise,
Very nice.
I can analyze the data through the line graph or something else. But when we want to know the distribution of the data, then histogram would be the appropriate.
Yes. So very nice,
Thank you.
Kuldeep. Very good. So Kuldeep is saying that now, Kuldeep, you can mute. Okay. So Kuldeep is saying when we want to see the data distribution, want to see how the data looks like in one dimensional. I'm not saying in two dimensional. So we can see the statistical distribution through histogram only. Okay, we can change the attributes of those data points in histogram only. Please put your note in your copy that you just only can change the statistical distribution of the data only through the histogram. If you don't know what is the histogram, please keep away for timing. If you have two variables, okay, for a layman I'm giving you this this definition. If you have a two variable and that one variable depends on the other variable, where the other variable is independent, so you always use the graph. Okay, so y is a function of x, so always you have x and y, some data points in x and y, you just plot it. But if you have only one dimension, one data, it doesn't depend on any other variable. For time being, let's say you have a data, I have given you Excel file where you have a x, and there is a random data. You can't predict that by seeing your eyes. So what you will do, you always prefer to plot histogram. If you have y x column as well as y column, then you always plot in terms of graphical plot, which is a graph. Is that clear, Mihir, to you? Now I'll come to the other who is asking me, Vikas. I think Vikas, or I did some analysis using image. Yes, this is the application. Yes, I'll come to your graphs as a smooth curve, no gaps between the bars and the histogram. Very nice. So the Kuldeep has given us a very correct answer. When you have a data and you don't know anything, you have x column, n number of data, you just plot it a histogram. Continuous discrete, please don't explain this, don't give this definition. I don't agree with you. So how can we say that the slide 70 is not a graph? Okay, let me come to the slide 70. So then meaning you, at which point you are not agree with us? 70. Very nice participation. This is not a graph. Very good. Just let me come to your point. I am not. So how can we say that this is the same question raised by Mihir, na? Yes, 70 is not a graph. Very good. Let me come to your answer. I'll not take again the class of graph and again the class. So 70 is this. Okay. So don't please. Events is the counts, the frequency of the mass you are producing. So here you see those data is randomly distributed. This is coming from the experiment. If I change the binning, it will change. Okay, but this is not, this is the counts. Don't see that, okay, this is the white background, so this is always a graph. No, no, no. This is what this says, events per this count is the unit of this minimum minimum scale of this scale. Because this is the frequency. This is the one-dimensional data we have. That's it. This is the statistical distribution you have. And you have filled in terms of binning. So it is showing you this. And this dot is data. This is fitted. And these are the error bars. I'll show you, don't worry. I'll also come to the GNU plot and I'll ask you the same thing. What is graph? I must say, y has a some value of x. And the y will stand on that value of x only. This is the graph. But in this plot, we are seeing that the x only the statistical distribution. Please, this is the events per on this scale. This is the count, the frequency of through which this m of mass of some particle is lying in this scale. Okay, Mihir? Maybe you could play some with your yes, you just let me know what you want to plot it with the graph. Yes, got it, ma'am. Okay. Yes, what Vikas, what you want to say so that I can start at my other part? RBG overlay method for image processing. Very good. So what you want to ask, Vikas? Can you speak quickly? Please, Vikas, you just speak it.
Ma'am, can we use root for the same?
So can you quickly let me know what you want to plot it in your mouth, from your mouth, so that I can explain you?
Ma'am, I just had some data about the COVID-19 of different states.
Yes.
So I tried to relate those data with the rainfall.
So then you then you directly use either this is also let's say the date and the number, right? So I think this is the number. Either you can plot it from the graph, or if you have a statistical, let's say day by day different data, you can plot it first one dimensional and also see the two dimensional. This is, I think, profile or the graph. Yes, you can easily do that. This is done in the root only. Okay. Yes.
Okay.
Yes. So it is open source. Now you know how to use that functions and classes. You please plot it and also let us know what you have plotted. Maybe we can help you in explaining those. Okay. That would be nice for us also. Okay. I think that was Vikas. These are the useful links I have kept for you. So as I promised, I was willing to hold some brainstorming discussion. So I did it partially here, where student took some very good participation and understand what is graph, where I should use. That is very nice. I kept all those slides for you people. I have already used those functions. So here we have done this for making a ranking of our institute. So let's say our department has weak in outreach activity and has a very good in research activity. So we have shown this using the root. You understood where we use this? Representing our institute in terms of ranking. We use this and I recommended them, and this is very useful. Okay. So the other thing I wanted to highlight you is please visit. If you don't have a root install and you still want to work as a virtually, there is this website. I motivate you and encourage you, visit, make some login. Those who are not having the Ubuntu login and want to have a flavor of how Ubuntu works without installing in your laptop or desktop or workstation locally, please log in. We have tested this platform and have a feel that using the root, we are making data analysis at virtual platform. Okay, please visit. I am encouraging you. Now I am closing this session of the root. Please don't worry about the assignments. The assignment is not given you to has some fear with the root, but you please open it up for your applications. Okay, and do some hands-on when you are awaking in night. Okay, now I'll start the next session in few seconds. Let's say if you want to bring your water bottle or tea, you can. Otherwise, I will start right away. So this is now I'll go into the GNU plot, which is another software tool for plotting and for analyzing. But why I started with the only root first, which is toughest task. Like I was not realizing that you people could do that. Okay, you made it, and I'm very happy that I can train those people who are not coming from my field, which is the high energy physics field. You are going a very good path, taking very good path in learning. So please utilize that. And if you face any issues in future, please let us know. We will help you. And then this is the final hands-on on. Okay, so should I send these slides to you now, and then we can do like we did in the root, or I'll do and you will enjoy there? I think you should not enjoy it there, but I should give you right away. I have not sent you the GNU plots, right? If I'm correct, I think I have not sent it to you. But today the invitation went for the, okay, validatory. So there is an email I can pick up, and I can remove those big person. Okay, let me send you the reply to all. And I'm sharing you few slides on GNU plot, and we will quickly, because you will not take time. Okay, this is because okay, I think new people are now connected, and this is the okay. So let me share you the GNU plot slides. Okay, and here is my final material, okay, PDF. I'm sending you the PDF, and don't worry, I'll send you the final all GNU and root exercises to you. So I'm just about to send you. Please confirm if you receive this final hands-on on GNU. I think yes. Okay, just open it quickly, download it somewhere and open it. So now I should close this terminal where I am, but I should go to the GNU terminal. Let me know if everyone has installed the GNU. Please confirm on the chat box if you are able to install the GNU. Okay. Please confirm at the terminal box that you install the GNU. So installation of GNU is very easy. I have also kept this installation material for you. I'm showing it to you on the screen. It is already distributed in the class or via email, those who have joined this course late. So installation of GNU in Windows is very, very easy. You just go to this website, download it, this latest version. These are the steps you follow. You will see this exe, click on the exe, double click, put an English language, accept their agreement. It will not ask you for money, and then 2 to 3 minutes time it will ask you next. Click on the next, and now you see, if you go to the start menu, this is for window user, you will see this for the window user. It's something like same for the Ubuntu. So click on the search option, then you are installed. after that you type GNU plot, it will give you this. So what it says, version 5.2, last modified, and this is some who invented some setting, and then this, if you see this, then you are fine, you should be happy. Okay, is that okay? You done with this installation in the GNU plot? This we have already shared with you during the classroom, also via email. Are you ready to do this? Should I send it again? I don't think I should send it again to you, because we have already sent it to you. Mail delivery for some students are failing to receive my email. I don't know why. So I'm again sending it to you. The students in morning also failed. I don't know who is. Okay, so you also got again one more email for the installation. If you didn't install it earlier, you please follow and quickly install it. If you have a good internet, it will ask you. It is not taking that much memory, so please you can do it. Let me come on for the Ubuntu user. Give some instruction. There is a 2 command. You have to open the terminal in your Ubuntu. Sudo apt get update will do the updates, and then sudo apt install GNU plot will install your GNU plot. Then again you will receive the similar command. Or I can show you. I'm inside in the GNU. I have made some GNU plot folder. Please, I'm not working on the terminal or desktop or download. I'm just typing GNU plot. So can you see this screen? Can you see this? So see GNU plot. Okay, so this is the GNU plot screen. So I have already installed it. For Ubuntu user, you just use these two commands quickly here. For Windows user, I have recently just sent you again that file. Now please confirm if you are done with the installation. Can you please confirm on the chat? Install. Very nice. Very good. Okay. Now we will start. The GNU is so why do the toughest task first, so that you should have a realization that, oh, we are done with the root. Now the GNU plot is nothing for us. Okay. So let me start with the GNU, the second file, which is a final hands-on GNU plot. And then I'll quickly go through and we will do enjoy with some hands-on for 1 hour. Now 3 is already there. So you can see my screen now. It's clear. What is GNU plot? GNU plot is nothing but the same thing we want. If we want to analyze, if we have a small data in terms of Excel file, in terms of DAT file, in terms of the CSV file, or in terms of I must say text file. If you have data stored in text file, txt extension, DAT extension, DAT extension, or some Excel extension, or some CSV files, you can better use GNU plot. But if you want to do some statistical analysis with a huge data like COVID-19 or some processing which Vikas has shown to us, I must say we should use root only. So you should be clear. If we are introducing you to software, it has some wide applications and advantage and disadvantage. Right? You know better how much you have the caliber, how much you have the time to spend on the software. But if you are a very hardworking faculty or a very hardworking student, and you are handling or working in the emerging area where you are handling a huge amount of data and analyzing and want to learn, then there is no age. You just use root, and then we are introducing you the GNU plot, where you have a small kind of data for your teaching purpose or for lab purpose, or a small, let's say in a CSV file, you just use GNU. There is no problem. Okay, but if you have learned already root, then the GNU is very, very, very easy. Okay, so let's start with very, very, very easy software. This is the link I'm putting for you. There is n number of materials available for the GNU plot, but I would suggest this website is more than enough for GNU plotting. Okay, this is how to start the GNU plot. This is, you have plotted sin x. So we will, so why I always start with the function? The way we started to learn the root, first the installation, perfect. Then we move to the, just have a feel how to plot already available plots, function. So we will use the same method here, and we will start to plot some function which is already available, and sin x is a famous plot, the function. So GNU plot, and then please open your GNU plot now and you will enjoy. So I am here to train you on GNU plot. So I have already, so for the Windows user, what you do, go to the start button, GNU plot, it will give you directly GNU plot. Don't go for the CMD, right? And for the Ubuntu user, open the terminal, just put GNU plot. If you are succeed in getting this screen, just do plot plot. Please open the slide number 2, which I sent you at 3 p.m. Okay, plot sin x. Okay, can you see this? But if not, if some student fail that, oh, I can't see the screen. How many student has failed to not to see the screen when you make plot and sin x? How many students? How many student fails to see the screen? Yes, Fatima is saying, but I have sent. Student receive the slides just right now. Please confirm. Bhavik, Mila, yes. Bhavik is saying yes. So how should I send? Fatima, I sent on the email address where invitation was sent to you. Maybe if someone knows, Fatima can directly forward again. If in that email by separately. Just wait, Fatima. Don't worry. Okay. Chitranshi, maybe you can help in the email. Yes, I didn't. Yes, some few students have failed. I received. Yes, so Chitranshi, you just look into this email. Why I'm asking Chitranshi? Because she is our own student, right? I can also ask Bhavik and all, because you all are now very good students, right? So yes, Fatima is writing. Please, Mohammed, you also, Hidyat, you also write your email, and Chitranshi is forwarding it to you again. Okay, there's no problem. Okay, we are here for you. Yes, yes, yes. So please also send Hidayat, Mohammed, Bhavik. You also send this person. Yes. No. Yes. You send it. Not a problem, right? We have. Okay. So how many students don't see this plot? There is a solution. If you don't see this screen of sin x, please open your installation script. There I mention you. Let's say here I mention you. Let me come to the here. Come on the slide number 5 directly. If you see on your terminal, this error is only for Ubuntu. I am mentioning. Don't fear the Windows user. Windows user is always easy task to do. Okay. There is a problem, can be a problem for Ubuntu user, where you see unknown and you don't see when you type plot sin x, there is no screen for you for sin x to display. So what you will do, you just do this sudo apt get install GNU plot minus qt or x11. This minus qt or x11, if you write whichever you want, will give you the GUI graphics, like in the root we were observing with the T browser. Okay, this you have to type. This is only for the Ubuntu users. Okay, I'm mentioning. Okay, I'll not go through each and every point. This is just I kept for you. Are you on the slide number 9? I am on the slide number 9 now. Are you? Please follow me on the slide number 9. If you want, I can give you the instructions, it is fine. Okay, I'll start with this. I am on the slide number 2. I don't want to go into the rush, but I am on the slide number 2. I have first plotted only sin x. I can see this screen. Confirm if you see this screen. Now you plot cos x. Please. So how you will exit from the GNU? Either quit. Okay. Ubuntu user will come down to the terminal and the window user will come, their screen will disappear. Like the route we were discussing. So it is the same. Okay. Now again GNU plot. And now I want to plot the cos x. So just write plot cos x. So there is a cos x plot for you. And if I want to plot a merge plot of sin x and cos x, you can also do the same. Okay, there is a option or there is a command for you, replot. First you have plotted sin x, then replot the cos x on the same. So you will see this. Okay, this is not an exercise, but this is just I am giving you that the GNU plot can do this thing also. Okay, can you confirm if you are able to compile the sin x plot in GNU? Can you please write on chat? Yes, very good. Compiled, very good, very good. I am happy that you are doing. Now I am on slide number 3. Okay, here I have just given you a brief discussion on the GNU plot. So why I am again coming back to the 3 slide? This is the website and this is the important PDF, which is the latest PDF. I must say, if you are using 5.4, you just go look into the 5.4, not 5.2, because the classes are updated in as per the version. Okay, where I got this? Here inside the documentation. This is the website and you have to just directly click on this. This is a very good manual for you, and there is a tutorial also. There is a demos also, which will lead you to look into those YouTube video available. So for GNU plot, I am not keeping anything as a reference slides for you, but I am recommending you, please you utilize this website, which is freely available for us. Okay. Okay. So you can see it here, which I mentioned that the Ubuntu user can see those errors which they cannot see. Okay, the sin x plot. So you have interactive session display. You just have a Qt or x11. So graphics you can only see. This is for Ubuntu user. In the window exe file, it is already there. Okay. Now I am moving to the slide number 4, which I have already spoken about. Please refer the installation script shared in the classroom and also shared today. Okay. Now I am on the slide number 5, which I have already spoken about, that there must be an error for Ubuntu user, which can be solved by installing or evoking the Qt at the time of installation of GNU plot. Okay. Now I am coming back to show you what we can do with the GNU plot. Okay. So you have a basic 2D plots where you can fill the curve like we did in the root. You can plot error bar. You can plot also histograms, right? So that is why I keep it as a last class for me. You can also plot a spider plot, some box plot, some circle plots, some math function where you can handle probability, random number, which we did for root. Okay, I'll point and I will ask to you only what at the end of this session, what is the basic difference of GNU plot and root. So let me complete this. 3D plots where you can plot the surfaces, the contour plots you can, and the density distribution plots, which we can do also in root. Some sample applications available for you. We can also read data files, text file. Okay, so how to start with the, let me minimize this, maybe this is too huge for you. Okay, how to start with the GNU? As I say that Ubuntu user, go to the start menu. For window user, my slides are already well explained. I think you should appreciate. Okay, So this easiest way, start with the function, which because it is already default function and you feel good when you see some plot. So there are different functions available like we saw in the root. Okay. So now you plot cos x, you already plotted it. Okay. And then combined plot sin x cos x, we already seen that. We can use replot command, replot. You can also, I'm on the slide number 10 now. We can also set and unset the range. We can also change the title. We can also change the log and the ticks of those plots. So you can see these are the commands and these are the description for those commands which will help you on terminal based command or on scripting inside the GNU framework. Okay, GNU plot framework. Now I am on the exercise number. So I have not given you the script, please, because we have given you the script for root. Now you are trained people. You are giving me the applications of the root. So I must say you just do some efforts. I have kept scripting here on the terminal, and I have already shown you there is a very good demos and tutorials available in the root main website, the YouTube links. Please visit. Okay. So how to save the GNU plot? That is the main thing which we need to understand. So you have to, if I plotted in the previous exercise sin x, I want to save it as a PNG. So what I will do? I will set my terminal in PNG with the size of canvas. I will set the output name of my file sinx.png with these, right? Hyphen set title of the plot which is coming here and plot then sin x. This you can do after that also and before that also. So whatever you want. So can you start this exercise of exercise number 2 of you have to give. So can you start this exercise please? I have kept I think different this PNG. This is not this plot I think. Yes. So please, there is a error. This plot is not that which I wanted to show here. Maybe this is a different plot I have kept and I merged those two things. So please, on the slide number 11, there is a correction. Okay. Right. It is maybe by mistake it is there. You just save a PNG of your sin x plot. So let's say I have plotted, maybe I'll again plot sin x and I want to save it. I'm doing hands-on for you. So there is a sin x. So there is no option you will find. Can you find how can I save it? No. Okay. This is difficult to handle this GNU plotting on the graphics user as a graphic user. What we will do, we will save it in these commands. So what I am doing, I'm just doing the copy paste. You have to type it. For the window user, I think they cannot do that, this copy paste, because the GNU plot in the root is maybe having some issues. It is showing like that, but this is not like terminal. Okay. So set output, you have to type it, please type it along with me. I have plotted first sin x and then I am doing this. Okay. You can also first set these things and then you can plot it. Okay. I'm just following the command which is mentioning here. Okay, so this will save me my sine plot in the PNG format. Okay, so where it will be saved? So let me quit QUIT or let me exit. Okay, for the window user, the screen will disappear. The same thing like you did in the root. You suffered like where those in the C drive, you will please look into the C drive. Your plot is saved there. For Ubuntu user, it is easier that your sine PNG is here only. Can you see this? Now let me go into the folder where I have this sine of PNG X. Can you see this? I have also changed the title. Okay. From -10 to 10, this is okay. So can I close this? And for the window user, please look into the where your GNU plot is saved. I hope this should be in the C drive, like in the root you were suffering. Okay, and you maybe few student has helped us. Okay, so if can anyone tell me in the LaTeX what plots are most useful to save for in terms of publications? Can anyone tell me which extension of the plot is useful for LaTeX publications or in LaTeX? Yes. Can anyone tell me? Are you writing? Oh, no, no, no. Which has a good resolution. Yes, you did it in PNG, JPG is fine. I am not asking what you did. Yes, Milap is saying EPS. Milap, what is the full form of EPS? EPS has a very good high resolution pictures, and this is you must say standard for storing the output for best publications in general, for best quality publications in general, I must say. So postscript, right? So please make your notes that in LaTeX you will save these plots. Now I'm on the slide number 12, please. Can you see this? Okay, so here I want to plot in using points. Here, what the SINX was showing me, maybe I can show you here where the GNU plot was there for me. Yes, GNU plot. So this SINX is like continuous lines, but I want to see the data points as well together. So what I will do, I'll change the style of the plots with line points. So what I will do on the terminal, this is GNU plot, you also seeing, set style function line points and then plot SINX again. Can you do on the same screen? Please do. If you are exiting from the screen of GNU plot, again type GNU plot, you will see this. Can you see this? And now I am saying that I have to change the set style function and lines plot. So I am now typing for you line points. Okay, can you see this? Enter, then plot sin of x. Can you see now points are also coming with the line? Are you able to do this? I am on the page number 12. Please do this exercise. Please do it and confirm on the chat message. Okay, I am on the slide number 12. Do it. I'll give you few minutes. Can you confirm on the chat message, please, that you are able to see the dots, points with the lines as given in exercise 3 on the page number 12. Can you confirm, please, on the chat message? How to exit from the existing plot is just, if you are Shilpa, user of Ubuntu, just quit QUIT or exit. Plot, the plot you can just cancel out. This is, let's say this is my plot. I am just closing, and if you want to come out from the screen of GNU plot here, you just put QUIT quit or EXIT exit. For the plot, you can just click on the close button on the top of your, right, while you are closing your browser, anything else. Shilpa, is it clear? I think yes. So I'm again going into the GNU. Yes, very good, Shilpa. So now I'll follow the next slide. Please follow me on, I'm on the page number 13. What I want to do as an exercise 4, I want to save the plot in PostScript, which I said is a very good gray, on the gray, you must say on the white scale. Like you, what you do? So you see the difference. If I put this on this page, they have, this plot is looking very nice as compared to the other plot in the previous slide. So what we do, we want to put all the plots in the LaTeX, in the EPS format in the LaTeX document in the next class. So what I will do today, I will set the terminal not in the PNG, but this time PostScript, an enhanced version, and the set out .eps is the extension of my file, and then plot it. Can you please try for me on exercise number 4 to compile? I'll also do with you. Don't worry. So this is easy or not? This is easy as compared to root or not? I think yes. So I am inside the GNU plot. I am just setting that my plot should be saved, and please look into that your plot is saved or not. Don't forget to look into that your plot is saved or not. Okay, PostScript and EPS. You have my slides. EPS and then enhanced, space enhanced. So is there error? I think not. It is saying okay, you will see the enhanced picture. So that, and that output.eps this time name, and then plot sine of x. Okay. So there is my plot. Okay, it is saved. Where is the directory for use for Windows user? Look into the C drive, and for Ubuntu user, please, I am inside the folder where I am working. So test.eps is created. I have not put it a title, so I can't see the title, but it is showing me that this is my plot with the very good high resolution. Can you see that? Or can you plot it at your end and confirm if you are done with this? So I can show you together what I did. Okay, I have just set the terminal for EPS with the enhanced version, set the name of output file which I want to keep. For Ubuntu user, in the same folder that EPS will be created. And for the Windows user, please look into the C drive. Okay. I hope you are done this. Now I am closing this. The file, Shilpa, you can click on the close. Go in again, visit this slides. So good option for saving in documentation in LaTeX. Try to save all the plots in GNU in EPS format. There is a correction EPS format, and add in your LaTeX document which you are going to use for publications. Okay, now I am on the slide number 14, please. So what we will do here, we will generate a 2D plot, which is, you must say in your language, it is a graph. Y is a function of x on the terminal. So the same command, you can make it as a script. I will tell you what will be the extension of script, how we will make, don't worry for that. Okay. So let's say what this command says. I am on the slide number 14, please. Set title. You are setting the title of, let's say, graph of the velocity versus time. Can you see this title will display here? Then you are setting the x label time, set time per second on x-axis. Then you are setting the y label velocity per centimeter, millisecond, okay, sorry, and on the y-axis. And then you are setting the range, because I'll not ask you now. In the root, what you will doing, you can zoom it on the display, T browser display, but here we cannot. This is a static plot. Okay, in the root you have a GUI, so then you can do whatever you want, zoom, unzoom, log. Here you have to type every command. This is the difficult for me at least. Okay, set x range 0.1 to 7. You can also set 0.1 to 6. Then set log of scale y. You are making it as a log y, and then plotting x times exponential of minus x. So you can see this plot. Can you start this tutorial with me? Please participate in the exercise number 5 on slide number 14. So I'm just quitting QUIT or exit, clearing my Ubuntu terminal because I don't like the bad terminal in front of you. Okay, so what I will do, I'll type again GNU plot. Don't forget to put a GNU plot, and then you will see this GNU plot. Yes, and then see set title. Please type it so that you know which key I am using. Okay, graph. I'm just putting graph. Okay, and then set. I'm just putting set X range. I'm not making labels for you. You can make it X range 0. I'm just making 0 to let's say 10 this time. So, and then what it is plotting here? Exponential. Okay, very good. So I am not okay. So what is the error? Can you see my error? Can you help me? Can you help me, please? What is the error here? What is the error here? Can you help me? How should I remove this error?
डबल डॉट आएंगे
Very
मैम.
nice, very nice. So I'm just putting you so that you just let me know. Double dot aayega, right? Colon aayega. Okay. And then there's no error, and then I will directly plot. I will not label here, but I just kept for you. You should know how much difficult it is. For me at least, I'm user of root. So okay. So can you see this? I cannot zoom it. It is very difficult for me, right? So it is fine. I don't know. There is a different forms that gridding you can do at least. Okay, you just play with those options, minimum options you have. I did it grid on clicking this. Okay, the same I shown you in the root. Is that okay? Are you done with this? But I have not set the labels. So if I want to save this, then what I will do? I will do set terminal PNG. Okay, then it will automatically save, and then output name of the output plot, that let's say exponential.png. It is not always necessary that what you do, you set that set attribute first, set the terminal first. You can plot it and also set it. Okay, I'm clear to you. I think I'm on the slide number now, moving to the 15. This is I wanted to highlight to you that where the user should know what can be done with the GNU plot and what can be better done with the root. Okay, so this GNU is mainly used for analyzing the data which has in the file, which are put already there in the file. Those files are not root file, but those files are, you just make your notes please. Those files are the CSV file, the Excel file. GNU can read those files. Please remember CSV file, CSV. C stand for cat, S stand for strong, and V stand for victory. CSV file, I should mention here. Excel file, text file, TXT file, and dat file, .dat file, DAT file. Those data, if there are some experiments, store the data in terms of those where we don't need a huge statistics, but only try to plot the graph or a small histograms. There you must use the GNU plot, I must say. Okay, are you agree with that? So this is the command. If my data is in terms of this, right, X and Y column, I want to read those data. So let me show you in my screen. So let's say maybe I can show you here. So can you see this slide number 17, please? Yes, you can see. So these are, let's say, in .dat file or CSV file on text file. So here time is given. Some experiment has been done where two variable, let's say current and voltage, are measured with respect to time. Okay, so what you have to do, you have to read that data and plot a graph. So Mihir, now you understood where I should use the graph, which you raised the question in the root. So if your data is like that, where you have y as a function of x, and there is okay with respect to time they have measured, you better plot graph. And if there is a limited data, better use the GNU plotting. Okay, if you have a huge data to analyze, statistical data to analyze, continuous data to analyze, where you have a regular data coming, and you cannot handle the GNU plot and the CSV file and the DAT file. Okay. So now we will run this exercise number 6 on our. So what you have to do? What I did, I'll tell what I will do. I will go into that folder where I am running GNU. So I will quit it, the GNU plot screen. Okay. And then I will make my own file, text file or DAT file. So here I have already made for use in morning. So can you see this? I think yes. So here I have just copy pasted those data. This is time, this is X, and this is Y. You can write all your data, or you can use the data which you have from your experiment. Please copy paste like that in your DAT file or text file. It is for Windows user, please use text file. Ubuntu user can also use copy paste and text file, txt. For Windows user, please use Notepad always. It is the easiest for editor for the beginner. Please, Notepad is already in your Windows, so please use editor, the Notepad for the Windows user. I would recommend for Ubuntu user, use Emacs always. This is a very best, I must say, or gedit. Okay. So now what I will do, this is I have to do here, whatever the written GNU plot, then set title graph, set label, plot. What this command says, plot from this file, which is the .dat file. In your case, this is .txt. Use the command, use the column 1 and 3. 1 and 3 meaning 1 time and 3 column is Y. And then the title Y should plot with the lines. So this is line you will plot. This by mistake that was kept here. Okay. So this is correct slide. So you please try exercise number 6 on page number 17 of this slide. Can you do that? Please copy paste this in terms of .dat file if you are Ubuntu, or in .text file. If you are Windows user, copy paste in Notepad and save it as a text file. It is default save it as a text file. So I'm doing for you GNU plot. Okay. Now I have a screen of GNU. For Windows user, it is difficult for the, so I'm setting the title on my GNU screen. You have to type it, Windows user. Okay, so it is showing me wrong thing. So what I will do, I will put an enter. I will again just plot this set title, some small title, because this is taking set title. I'm just typing for you, and then one, then graph. Okay, so it is not giving me the error. If you copy paste, it is taking the second line, so it is showing me the error. So please make sure that don't copy paste every time. If you have, so I have made it a small title, then X label I am putting time, and then I am plotting. I'll plot in front of you. I'll not copy paste it, but plot it. So what I will type here. Please do with me, plot, not, okay, plot, the file, this is the single, then what is the file name, dat, Control C also you can say if you are going in the wrong direction, okay, use Control C, set, set, this plot, sorry, plot, data, .dat, data.dat is I kept in front in the same folder, and I have copy pasted those data which you can see here. Okay, and I am reading the column 1 and 3. You can also read the column. So I'm not putting a title Y with the lines. Let's see what it comes. So you just see line is not coming. Can you see? Only data is coming. So if I forget to put this with lines, set Y lines, it will not show me lines. So now I want to again put title Y with lines. I want to show with lines. So it will show me the lines now. Can you see this? Otherwise, default, it will take the points. Can you please compile this exercise number 6? This time I am not giving you the script or anything, because terminal we also did in the root the same way. You were doing along with me. We have last 20 minutes, so please do it together so that you learn. Let me check if you are facing some issues. Yes, ma'am. I have one question. Bhavik, can you ask? Yes. You can ask, Bhavik.
Ma'am, in my GNU plot output, there is a direct option to save this file. So I can
Acha.
directly do it.
But in
Directly
my,
in
I
PC.
cannot see. Yes, yes, you can. Here, where you can
Yes.
see. Here?
No. Here, yes.
Maybe, yes, yes. It is. You can show me. Yeah, yeah, you can save it. You are using window?
No, I am using Ubuntu, ma'am.
So, which Ubuntu?
Ubuntu 16.0 for LTS.
Yes, yes. So actually, as I said, I'm using. I am, because of this recording purpose, I'm using the my own old Ubuntu. Maybe I can check with the 20. I have Ubuntu 20. So it is
Ma'am,
fine, Meher. Yes.
there is
Very
some
good.
DAT file I have that
Yes.
was from Quantum Expresso, but there is no x-axis and y-axis, and there is a lots of data. So how to solve that thing?
No, no. What you can do, you can save it. There is an option to save, let's say, in terms of text, in terms of text file txt.
Ma'am, it is already in DAT file, DAT format.
Okay. So no,
There
no.
it is.
Our aim is to just open a new file. Okay. Just copy paste this data here from here.
No,
Just
ma'am,
listen carefully.
I got that. That is the .dat file, right?
Okay.
And we have to put that graph regarding that DAT file.
Yes.
But in future, I have
Uh-huh.
to work on Quantum Expresso. So there
Okay.
is already some simulation I did in my master's project. There is a
Yes.
DAT file that
Yes.
was
Yes.
ready. But
Yes.
how to plot that? Because there is a lots of data.
Yes.
Approx.
So
So
yeah, yes. So let me come to your answer. First, Mihir, you have to arrange your dat file in terms of column. You have to clear it, and there is an option. Maybe I don't remember now, but you can make it your column wise data, right? You have to prepare your column wise data. You have to arrange your data, and then if you want to analyze that, you have to read those column only. This is all you can do with the GNU plot. But if Meher, this is the problem, that you are not be able to understand the column or the row in your dat file. Is that the case you are saying?
yes, ma'am.
Oh, then what you can do separately, you can send it to me after this session, after your LaTeX session. Maybe I can help you. Okay, I can
Okay.
suggest you something. Okay, on screen I
Okay.
cannot see clearly. Okay.
Okay, ma'am. Okay.
Very good, very good. So very good, Meher, that you are raising the points that you have already dat file, but you are not be able to. But there is an option to set all those commands. So don't worry for that. We have Ubuntu. If you are working in Ubuntu, that is fine. You will be able to do that. Don't worry. Okay. Now I am moving to the slide number 18. Please, along with me, do it. We have a 15 minutes. So what is the GNU plot in terms of 2D? You can utilize one graph plot. I have already said. In terms of 3D, you can plot S plot. S plot meaning bole to surface plots, right? So there are three kind of representation. I am showing it on my screen to you. The surface plot, this contour plot, and the density distribution plot, which we saw this plot in the root. We can also plot this in terms of root. But how in this GNU plot? There are small commands written. So I will say this is the class of PM3D map in terms of GNU classifier or configuration. There is a surface, set surface is again a 3D, but you are removing the Z, then this is only showing the XY plane. So if your Z is a function of X and Y, and the data is stored in data.dat, then you use this representation, I must say. Okay. Okay. And now I will tell you how to plot those things in terms of surface. Let's say I'm giving you a tutorial on the surface. So here on slide number 19, I'm introducing you that this kind of representation you can read from the dat file which you have a data and show those graphical distribution in terms of results, plot it. And now here I am doing the one hands-on for you, or on the 3D plot of the S plot, where you are going to plot the surface plot. S stands for the surface plots. So can you do it with me? I am on the page number 22, exercise number 7. Okay, so please ask, like Mihir is asking in between, if you have you are observing those words which I'm speaking, the dat file and where to use, why not to use. So please ask, I will be happy to give you the answers. So I'm just I'm inside the GNU, I'm just plotting the S plot. Okay, I have to set the range with column. So please set the range, set X range. Okay, here I am plotting the function, not coming data coming from the other file. Please remember, set X range. I am on the page number 20. Set X range 0 to 7. You can set 10. I'm not obeying all the which I have written here. You can change your set range also. Have a feel how this works. Okay, and then 1 3. Okay, let's say 1 3 I have plotted, and then I am plotting S plot exponential. Are the window user able to do that? Please paint if you are facing any issue. Okay, write it. Chantal, or you also point me if I am unable to answer. You just let me know when the student is asking. Okay, and then some function you can plot. It is just a function. Why I kept this a big function? Because here you see X and Y. This complete function is, let's say, Z, and the Z depends on X and Y. So I'm just plotting like that. Okay, so this S plot is here. Can you see? Okay, so what is on this? You see, this is 0 to 10. What that 0 to 10, which I kept for here, X range. So this is my X range. This is 1 to 3. I have not kept 1 to 5. So this is just wait a minute, Y range, and this is the Z is equals to your exponential function. Let me come to the chat message now. Okay, done. Oh, very nice, very good, Ankita. Thank you. Also, we can directly save it, but PLT. What is Muhammad is? Yes, in Windows also we can direct. Yes. This is very good news from the student side, that actually I'm not a good user of Windows and I don't like Windows, but many students were approaching me that if those two, when we advertise, the student are asking me about the operating system. So I said that, okay, take this risk and I will also learn. So window is also, I have some window configuration, so I am just making it for you. So you people are doing very good things, that you are informing us that there is a directly option. Can you remind me? I think this Meher already informed us that the Ubuntu also has. So maybe my configuration or GNU plot in Ubuntu, I have a previous. I think I have a, if I am correct, my GNU is 4 point. So maybe this is the only reason. Yes, this is the old GNU I am using. So in my new machine, it is 5.4. I think perfect. Thank you. So please remember that you can directly save your plot in terms of what you are saying, .plt extension. Why not .png and EPS, Mohammed? Is that there in any option? If not, then you just use those commands. Are you happy, Mohammed? You can use set, terminal, PNG or EPS. I would prefer to save it in the EPS only. Okay, so please move next. We have now 10 minutes left. I am on the page number 21, slide number 8. If you want to plot PM 3D class, what is the PM 3D class? It says that I will not show the lines in the surface, but it says I will show the density distribution or the layer kind of distribution, shared kind of distribution in the surface. So there is an option for you. You have to set this is the same thing. You are using the range, and then there is a option unset the surface and ISO sample it and unset. Set the surface meaning you are putting like that, and then you plot it the new function. Can you try your own the exercise 8 on the page number 21, please? Can you people do that? I'm here on page number 21. Be quick because we have another session starting from 4. Please do it and let me know if you are getting not this distribution but the distribution on the page number 21. What you have to set is unset the surface and set the PM3D. It will show you this kind of distribution. Okay, this is very easy. Like if I know root and I know the nomenclature of all the histogram graph and I know how to work on the terminal, I'm fine with also using the GNU plot for small tasks.
Done, ma'am.
Done, very good. So that is why this was my aim, to first give you the toughest hands-on on toughest software, so that you will not be lazy. If I start with the GNU plot, then you will not recommend to use root, I must say, because if we have a habit of using the easiest things, then we will has a hesitation to move the toughest task. If we are done with the toughest task, it is easy for me to complete GNU in one session. Is that okay? Are you agree with me? I think you should. Okay. Now I am on the slide number 22. Okay. So what the GNU plot can also be used if you have some data points, let's say, and you want to fit it. Can you see this? I am fitting y equals to mx plus c line on the data. This data meaning you have a data in your file. You are plotting a column 1 to 2, right? With m and c, where m and this are slope and this curvature, and that set title is the title of your distribution. Labeling of your make a labeling of your distribution and the plot it. This file is, you should keep your data file in the same folder, and then you fit it. So you just fit it. So please don't forget to copy all the command together, because this fit on the new line will break in your GNU plotting. So please better you write it. Okay. So can I show you this? This is the red point is the data here, and this is the line. This is the line, the green line. Okay. And this is can you so this I have not kept any data for you here, so you just see this. So here it is important point I forgot to highlight is, you just see this will also give you the fitting parameter. Can you see? Maybe I should zoom it out. Okay, I should zoom it out for you. Okay, can you see this? So this will give you this. What is fitting? Fitting is when you have a data and you are explaining your data with some the functions which you know this your data behaving like that, and there should be a minimum difference of your fitting function and the data. If the fitting function and the data has a minimum difference, you should have a minimum chi-square fitting. You say square root of the chi-square. So this will give you the fitting output when you use this command. Okay. So now this is very easy. You can do, if you have a data, you just fit it. Okay. The same, you can take the data from the previous this, and you have a kind of this. So you just plot it. Let's say you stop your data here, you fit it. Your mx plus c will change. You have to change your slope and m and fit with the straight line. Okay, the same data you can use. Now I am on the slide number this. Okay, can we do this now? Because fitting the data point with the error bar. If you are, so again I am showing you the same thing, but this time with the error bar. So your data should have x and y and the error on the y. Okay, position, error on the position. So this is my x, This is my y, and this is the error on the position. I'm just using this line, and this is the fitting output which I will see on the same GNU plotting screen. And this I have so this is the labeling again we did today. This is the command. Maybe I should plot it. Make it as a zoom large. So you see, I am just fitting mx plus t. Data is coming from my file. I am plotting 1, 2, 3 or 1 or 2, and then I am using this with the best fit command, and then you can see here. Okay. So this this is the last slide. You please compile it. I'm this time, like in the root, I'm not giving you the script. You just copy paste, make, please. Now you know how to make your own file, dat file or exe csv file or text file for window user as well as for Ubuntu user. If you are making your own data file, you make it as a text file. If you are taking the data from, let's say, dat file, the dat file also can be readable from the GNU plotting purpose. And then here we have a histogram, the same thing which we did in the root. We can also use bar histogram or the continuous histogram, right? So this is just you copy paste. This is the same link which I have given you on the slide number 1. Okay. And this is the application. So I'm not plotting it because the histogram we have done the same time. You have to just copy paste these commands and understand. Let me explain you something in the histogram. So this is, let's say, data I have to make it an histogram. So select the histogram data. So this line will work for you. Set style data histogram. That's it. The data is there on your file and you have to plot it in the histogram. And then again, just style, fill, solid, border, and there are n number of attributes you can change. Okay. So now I should come to the slide here. This is the one of the application which I want to highlight. I also given you the application in the root just 1 hour before, right? So the one of the student has asked me, oh ma'am, this I can also use for this. So you see, I don't prefer to use the GNU plot if I don't know the root. Okay, that is fine, because the writing part on the terminal or on the screen is very bad. We have to make sure that we have not forgot this colon, comma, and then the text file or the labeling in the proper format. Because I don't think, if you are the user of Ubuntu, can you check that if you are able to change the attributes on your plot itself? Because I can't do that in maybe in the new old version. Can you do? Can you confirm? Because this kind of analysis or this kind of representation is bad from the this, because you have to take care colon, dollar. I don't know. It is if it is good for the student, or when you have a very good practice. Labeling, small plotting, histogram is fine, but for this kind of representation, I must say use the root better. It is okay. This is my last slide. Now I open the session for again some brainstorming, where you will now you know what is the pro and cons of the root, what is the pro and cons of the of root and the GNU plot. So you just decide. Now you should have that brain to decide which software I will use. So let me answer some few of the questions. Image can be saved in the PNG, SVG format in window. It is the compiled GNU plot file. It is being saved in the PL. Okay, ठीक है. But Ankita, maybe use then set terminal commands which I have given in the this file. You can save it. Okay, PNG is fine, but EPS is it? If it is not possible, you have to go for the EPS because it is good for the publications. It is a very good has a very good quality in terms of LaTeX document. I would say you all people should save the output from root or GNU plot in the ESV only. Okay, in terms of presentation, not in LaTeX, you are sending it to your supervisor, or you are sending it to your the collaborator, or discussing together, you must use PNG. But if you are going for the publications and now you know how to make the the LaTeX document, I would prefer please go EPS. Okay, and if you are using overleaf in terms of LaTeX, I must say EVS is fine. Okay, I have a question. I'm facing a huge having a huge data, and I want to analyze then which is better. As I said, if you are handling huge data and you are reading those data your own, and you are analyzing those data your own in terms of processing, right? I must say you should use root, not the GNU plot. Okay, and if you are still not confirmed here, you can send me one of your file. Maybe I can guide you, or I can suggest you. Okay, the next question is Vikas side. Can we plot data simultaneously generated by some simulation software using? Yes, of course. Why not? If, as I have been asking you and speaking again and again from the first day to till now, that if the data is coming from these simulations and the data is saved in some format, right? There is a possibility, there is another software Gian4 which already interfaced with the root. So we already the Gian simulation software is storing the data in terms of root files. But if you have some files, let's say dat file, and but these are files of the huge file, Vikas, you can read those dat file also in root and analyze them with the .c extension file, which we did, right, Vikas? If I understood your question correctly. Yes, you should go with the root, Vikas. Okay, if any other questions you have, you can please ask me. Yes, okay, ma'am. Okay, because thank you. Any other question from the brainstorming side or from the compiling side? If you face some issues, even after this completion of this STC, you all are welcome to email us, point us where you want to. If you need some consultation, if you need some help in understanding, in deciding where to use, what to use, which this is my file, you please write us. Okay, we are guiding all the students which are in the MNIT and outside the this country as well as inside the country, so we will also help you. Okay, now I will not waste my time, and if you have any question, you can point me in the email. My email address is kavita.phy@mnit.ac.in, which you have already in your mailing list. So now I would like to thank you, all of you, and I'm happy to see your responses late in night and very early in the morning. So now I think I will invite Ritu ma'am. Ritu ma'am is there?
Yes.
Yes. Okay. Thank you, Fatima. So please be connected. Ritu ma'am, if you want, we can give them 2 to 3 minutes break if they want to have a cup of tea together.
No.
Because yes, they are working since 2 o'clock. Okay. So yes, yes. So please, 4, 5, you can take 3 minutes break for taking some tea with you or coffee, right? And then, please be connected. There is another beautiful session for you, which is on GeoGebra by Dr. Ritu Agarwal. Okay? Yeah, yeah. For hard working, yes, we have to hard work, Fatima. Otherwise, right, we have to always do a hard work. So okay, so I am now muting my the Ritu ma'am recording is on. We will not stop the recording. Okay,
Okay.
let them take I think break for 2 minutes. Okay, thank you very much for all your attention during the session. Okay,
Thank you, Kavita ma'am.
yeah, yeah. Hello, good afternoon, everyone. So this session I would be taking on GeoGebra, and this some part of this has already been covered by Professor I.K. Rana from IIT Bombay. So I will continue that. So I will show here in this session, I will show you few examples uh, to reveal that how GeoGebra works and how much creative you can be to create your own diagrams, your animations, and you may use them not only in your learning to teach your students further, to demonstrate geometry. So for many things you can use GeoGebra. Okay, so here this is GeoGebra Classic 5 or maybe Classic 6, and it is also available as an app for mobile phone, iPads also. So you are not required to install it like a full software. It is you can work on the app also. Okay, me here I will talk about the due date of assignment later. So there are many windows, but the basic is the basic are these three parts. One is where you can see the algebra, another is where you can see the graphics, and then the properties of all the graphics. For example, here right now you can see the basic x-axis, y-axis, and the grid. So you can modify your dimensions from here, like what the minimum value of x you can see on the window, maximum value of x, minimum value of y, maximum value of y. And suppose you are using this, so you can see that as you are changing the view, here the values are getting changed. And also the proportion, sometimes for a smaller value of x there are very large values of y, so you can change this proportion also, for example like 2, 3, and like this. You can see you can do like this also. So this is just like you make change here and click on the graphics window, and that change will be applicable. You can change the axis pattern, like here what should be the line style, how you want to display your axis, what should be the label, how it should be labeled in serif, bold, or italic. You want to show axis or don't want to show axis. So there are many configurations you can do. You can check here labels, like you can give different labels also. Units from here, pi, mm, cm. So these are the standard units. Most favorable are like for mathematicians and those working in signals and all, that is pi. So for y-axis also similar type of fields are available which you can customize. Then here you can see 2D graphics, and this is the input bar from where you can input a function, just like suppose I type y equal to x, and as you type it is displayed. Okay, just press enter, and it has given the name f. You can customize it, you can change the name. Suppose you say it is a line, or you can put it as a caption line. And but here in that case you want it to be replaced as name and value. You want to label it as caption only, or the caption and value. If I'm saying caption and value, let us say line, and here let us say it is L.
Then you can use touchpad to change the view. Okay, you can move this line, your caption from one place to other. You can shift according to your convenience. This is for moving this. Okay, and if you want to change it, the slope, then let us say it is 2x, the slope can be changed. And in fact, you can make it like you want to change the slope. So what we can use the sliders for the various values of m, how the line looks. Let us use a slider here. Click on this window. I explain it again. So here you can see this. When I'm placing my cursor over here, you can see there is slider. Okay, so go here, there are certain options: slider, text, image, OK button, chat box, input box. Okay, so from here take the slider. Let us, slope is mostly denoted by m, so let us denote it by m. Okay, it may be -5 to 5. So you know the slope varies from -infinity to infinity, because m is basically tan theta, and for theta from -π/2 to π/2, it takes -infinity to +infinity. Okay, let us define the increment also. Let us say it is 0.1 or 1, whatever you like. Okay, and then I make the change in line. I make it, instead of 2, I make it m into x. So what will happen when I change this m? You see, you can see that the line is moving. Okay, so for this you have to be creative. Similarly, I give you another example. Let us say I define another function, y square equal to 4ax. Everybody knows that this is equation of parabola. Okay, so because here the input I gave here a is not recognized where, because here a is not defined anywhere. X and y it recognizes as the variables of the axis. So for this it is asking that create sliders. Okay, let's create slider for a. So when I change the value of a, you can see how the values are affecting the shape of the parabola. Okay. Similarly, you can create many shapes here, and you can customize, you can animate. Now, to you are seeing it only in black color. If you want to change the color, so you are going on this equation. Okay, so here you can click on object properties. So that is, you are already seeing on right hand side. So from here you can change the color. You can select any color. You can change the opacity. Right, this is like filling it with some color. If you want to make a solid diagram, you can use this. Then there are certain style, line style. You can take it line style. Various line styles are there. Right, and along that line thickness, you can define line thickness. Line opacity, how much transparent it should be, so you can decide from here. So there are many parameters for the customization available, and you can play with them. Okay, there is an inverse filling, so this is inverse filling. Okay, so these are few, and then you can put your caption here. Caption is like, let us say you are writing parabola, but then you have to show caption and value. Okay, so the caption and value, you can see here, it's shown here, parabola, both caption and value. Okay. So you can bring it within the range. Now I show you some simple curves, more simple curves. Let us say y equal to sine ax, right? But now as I change the value of a, you see, for time being, let us uh, not make it visible, the parabola. So here you can see sine. Okay. Just by changing it, you can see it from here. Let us say t x raised to power a. When you change the value of a, you can see again. Let us make them invisible. So here, just you click on this blue circle, and you can make it display on and off. So this is x raised to power half, right? So this is x raised to a minus 3. Then this is x raised to a minus 2. Right? You can see how the curve is changing, how the values are affecting. It is even function or odd function at certain points, while it is only one-sided at certain points. This domain is limited, defined only for x greater than 0. Okay? And here, this is x cube. So now I show you certain examples, like this example. Here you can see the parametric curves I have defined. So this is a parametric curve, which is t cos t and t sin t. So this is nothing but a spiral, which is t raised to power t, and when you write it in parametric form, then it is like this. And here the range is from, you can see, when I double click over it, you can see here it is t is from 0 to 3 pi. Right? So simply type curve here, curve, and it will help you to write, to see what you can fill for creating a curve. Okay. This is another curve, which is 2 minus 3t, 1 minus 5t. You can see from here, it is equation of a line. It is linear in t, so it is equation of a line. Okay. Then this is 2 plus cos t and 1 plus sin t. So this is again parametric equation of a circle, but where the circle is, the center of the circle is at some other place other than origin. So this you can see here, this big curve. Okay, then this I have created piecewise continuous curve. So this is t comma t, which is a straight line, t comma 1, where x is varying with respect to t and y is constant. So this is a line parallel to x-axis, right, between 1 to 2, and then 2 to 3, it is a line with negative slope, and y is changing and x is constant. So this way you can create parametric curves. Now I show you one more example. Okay, come to this example. Now, when you want to explain Fourier transform to your students, and you want to explain the principle of superposition, how will you explain it? Okay, for time being, suppose I am having two signals. One is this, fx is equal to fx is equal to sine 2x plus 4, and here it is not only 2 and 4, it is actually, you can see from here, sine ax plus b, means I can change the values of a and b. So for these values of a and b, I have used the sliders here. Okay, so let us close it, and when I change the value of a, then you can see the density of the waves is changing, and when I change the value of b, then phase is changing, right? So both the wavelength and density, both are wavelength and like phase, you can change. So here, instead of defining it like sine 3x plus 14.5, I have defined it as sine ax plus b. Okay, then I have another two sliders. They are c and d. Therefore, the another function. This is d, which is also again defined as sine cx plus d. Okay, so when I change the values of c or d, so d is the phase for this another signal, and this is for the wavelength, right? Now, if I want to explain the superposition of both of these waves, the superposition is linear sum. Okay, so here hx, you can see this is linear sum of f and g, fx plus gx. Okay, so let us make it visible, and for time being, let us make gx invisible so that you can see what is happening. So if I change the values of a, let's see, right? Let's make g also visible. Values of b, then phase is changing, right? Then I change the values of c. So this is the superposition, right? If I change the value of b, then you can see the phase is changing, right? So this way you can explain very well the superposition principle to the students for many parts of your curriculum. Okay, so be creative and try to make yourself aware of the concepts. Now, one more example I have taken here. This is most of you have studied the solids of revolution. How will you explain the concept of how to create a solid of revolution, right? So what I have done here, I have defined a function. Again, you can make it arbitrary if you want to play more with the function. I have taken a fixed function that is minus 2x raised to power 4 minus x cubed plus 3x squared. Now teaching the first year students has become very easy because what programming I have already done. I need to just change the function here. Okay, changing the function will make it all changes. Okay, so I have taken this function here. Now, what is the command I have given here? Intersect the function with x-axis and its first 0. Okay, this command is for intersect f with x-axis and 1. If I make it 2, it will go to second 0. If I make it 3, it will go to third 0 and so on. Okay.
Ma'am,
Yes.
sorry for interrupting you. Can you make it, let's say, if your background noise, yesterday also you just switched on your fan.
Oh, actually, I think there is some problem with my microphone.
Okay, if it is possible, you can change. Otherwise, you continue. Sorry for disturbance.
I don't
Okay.
know, that's okay, but actually my other microphone is busy with my daughter.
Okay. Not a problem. You continue, huh? Continue.
If it is more, then I will ask her to if it is disturbing more. Okay, so I was talking about this revolution. Okay, so you should know what are the concepts and concepts of geometry. So what you need is actually the good knowledge of geometry, that you need the points of intersection because this is infinite curve. So for defining the solid of revolution, you need a finite dimension so that you can revolve that solid. So the range I have taken is from first 0 to second 0. Okay. So I cancel it because I don't want to change it. So this is basically intersect f with x-axis where the function f is intersecting with x-axis and its first 0. So it has automatically calculated the value and the value here is minus 1.5 and of course y is 0. Then next draw a line at A and y this is parallel to y axis. So this has basically become your wall from where you will start. So at A you have created, you have drawn a line parallel to y axis. How you know that what is the syntax? You simply type line here, so you can see point, point, point parallel line, point direction vector, or linear eccentricity conic. So we are talking about line. So I have taken point and the parallel line, that is y-axis. Okay. So this is a line parallel to y-axis. Then this is a point on x-axis, which is starting from the lowest value minus 1.5, which is 0 of fx. Okay. Then next what I have done, I have drawn a line from, I have drawn this point a comma fa. So when my point here, this is a, so if it is a, then this point b is a comma fa. Okay. Then this point c is a comma 0. Okay, that is a point on the x-axis. Then what is h? This segment BC, this is h. So here you are seeing just the value, but here you can see what is the command behind this. Then what I have done next, that is circle with center C, radius FA, and along the x-axis. Okay. And then this D is the third zero of this function f with x-axis. Now this is the 3D representation for the same graph. Here you are seeing it in 2D. Now here you can see in 3D, because the circle, you are taking the direction x-axis. So now you need 3D. So let us animate this. I am doing nothing but simply using the commands available already in GeoGebra. So I am doing it animation on, and you can see how it is drawing the circle and creating a 3D diagram for this solid of revolution. Right? So why it is going beyond that? Because I have given the range for A, that is beyond this point D. If you want to make it till D, you can give the range to this till point. So go to object properties, and from here you can define the maximum value. Okay. So maximum value is 1, so you can give it to 1. This way you can do it. Right. So this is the way to explain the concept of solid of revolution and how the solids are created with the symmetrical shape when it is rotated about x-axis or y-axis. Okay, you can increase the increment for A can be, you can make the step size smaller or larger as per your requirement. Okay, so this is one example. I give you one more example. This is solution to ordinary differential equation. How you can draw it and how you can make it, customize it. Okay, so here this B is like a point which we have defined. We'll see how it has been used here, and we have made it a slider like this, right? So basically B is nothing but the point like initial condition, because you know for first order ordinary differential equation, what we need one condition. For second order ordinary differential equation, we need two conditions. Okay, so here the differential equation, the ordinary differential equation is like dy by dx equal to fxy, first order and first degree. Okay, if we are taking it linear, then there is no multiplicative term for y, right? Okay, so for the standard form dy by dx equal to fxy, what we have to do here for first order ordinary differential equation, write down the fxy part. Okay, and there is input box So input box you will get from here. Here this is input box. So when you click, you select it and you get it here. You can customize it, like if you take it input box, then you can give the caption and you can link any object from the drop down list, whatever you have defined here. Okay. So here the input value I have taken is dy by dx equal to fxy, which is 4x cube plus 2xy. You can change it. I will show you what are the effect if you change it. Okay. And as you type it here, you can see this is automatically changed, right? So this is the advantage of using input box. After that, here see the command. What is the command? Solve ODE. So GeoGebra is very simple as compared to other computational softwares. Solve ODE with right hand side fxy. Okay. So solve ODE fxy. Okay. So when you do this command, it automatically shows you the answer. Okay. It is displaying answer on it. So here you can see the complete solution. Then here this C1, if you see, this is a slider I have created here, right? A is the density. Density of what? Density of this slope field. We'll come to this later on, right? This is B comma GB because now we have got the solution. So just to create an initial condition, what I have done that for the value B and GB, that has become our initial condition, right? And for this initial condition, here you can see this is the initial condition, x equal to -2, y equal to the same fb, that is -37.72, right? So here you are getting this. Let me remove this. So the solution of this differential equation is given by this curve, okay, with this initial condition. So if I change fxy, my solution will change. If I change the initial condition, that is for B, right, then that will also change. I have done the reverse process here, right? So this is the initial condition. Now, what is this next command? This is slope field. Slope field, whenever there is differential equation, we are assuming there is a flow, and you can see the slope field, that is the field of derivatives, dy by dx. So there is automatic inbuilt command, that is slope field. Here you can see slope field of, because dy by dx is what? fxy. So here you have to put the value of dy by dx, which is here fxy. Then A is the density, how close the slope field should be. What is the length? Length of the slope field. Then minimum value of x, minimum value of y, maximum value of x, and maximum value of y. Okay. So if I change the density here, you can see. So this is reducing, density is reducing, and here you can see it is becoming more dense. So stop at which point you want to stop to see the perfect diagram. Okay. And when I change this length multiplier, you can see the length of the slope field is changing. So it is maximum and reducing, because they should not interact with each other. So that's why even if I'm increasing the value of length multiplier, so it will take certain values and you have to define the range according to that only. Here I have taken arbitrary range just to show you. So here the length multiplier, you can see slope field here, you can see it is 0, right? So when I change it, it is increasing, then at certain point it is maximum and they have interacted 0.9. Okay. So for that, if you want to reduce the density or increase the density, so you can play with this according to your requirement to change the view of the slope field. Now let us come to this part where you can play with suppose this is 4x and let us say it is 2y. Let us see what happens. So just with a single click, you are just changing fx, y, and you can create solutions to as many as differential equations you want. And here you can see the solution also, right? So for this equation where dy by dx equals to 4x plus 2y, the solution is e raised to power 2x minus 1, right? For b equal to 0, if you want to create the initial condition, so for b equal to 0, you have got a is also 0. So the initial condition is when x is 0, y is 0, right? So this is a text box I have added here, and this text box can be added from here only. Here ABC text, right? And for this text commands, whatever you want to write, you can follow the LaTeX formula also, LaTeX commands also, and you can insert the symbols or you can use the objects, right? So you can use the LaTeX formula. So I show you what LaTeX command has been used here. So you see here, and this is text df bold. It is in bold. You can clearly see y dash equal to f line break. Solution y equal to g line break, x equal to b and y equal to c. So these are some input things that you have taken from your algebra part. They are already defined in algebra. Okay. So this way you can create a text box. So let us play more with this. So this is 4x. Let us make it minus x. Let us see what happens. So you can see not only the solution is changing, initial condition has changed, your slope field has changed. So now if you are writing a book or writing some, you are creating some assignment for these students, you can just play here and see whether it is having a feasible solution or not. Let us make it also minus, let us say 7xy. So I find it very interesting to play with all these things. All right, 5x square. Let us see what happens. So it is having only one-sided solution. So now you know the physical region also where the solution exists or does not exist. So the visibility make your concepts very, to understand what is happening there very easy. Okay, so this way you can play with first order ordinary differential equation, and density is for density of the slope field, and length multiplier, the size of this vectors in the slope field. You can change from here, but it is having a minima and maxima value, and you have to play with it, that range only. Okay, so now this one more example. This is also very interesting when you are seeing it in 2D and when you are seeing it as a 3D. Okay, so here t is the parameter, and ft that is cos t, gt that is sin t, and ht that is t by 4, right? So cos t, this is graph for cos t, this is graph for sin t, and this is graph for t by 4. So you are seeing them as three separate graphs here in 2D. But now if I take all these three together as a point, so now I have defined point A, which is cos t, comma sin t, comma t by 4. So now this has become a 3D dimension, 3D point. So when you see it here, right? So I have defined the point A based on t, right? And when I move this t, I animate it. Uh, just wait so that you can clearly see. So here you can see what is happening with this t, various values of t. You can see how the point A is moving. So this has become a spiral. So this way you can create many 3D graphs, and the command is so easy. What you have done, you have just taken a parameter, you have defined three functions based on the parameter, and then you have taken that as a 3D point, and this way you can create curves in 3D space. So this is one more example where you can find the area between two curves, bounded by two curves. So the command here is, as you can see, this is something like this. This is not part of the command. This is integral between. So there are already inbuilt commands, and you can explore for them. So integral between y and y square. So there are two curves, y and y square, and the range you have given, that is points of intersection. Even you are not required to put the values of points of intersection. You can simply go to 2D part. In algebra, you draw y square, and then ask intersect y and y square. So from there you can find what are the points where these two curves are intersecting, right? So this is y square, and intersection is on between 0 and 1, and it has calculated value for you. And even if then you have got its approximation value by using this solve numerically, so 1/6 it has given you the approximate value 0.17. So if you change the graphs here, the values will change, it will become a dynamic thing. I open one more thing. See? So here you can create complex curves also, but the problem is that you can, though you can see what is the complex shape, but it will require a lot of calculation to do. But you can do, you can calculate, find out the complex curve. One more example I want to show you is this. Okay, so any doubt so far? It will take few minutes to open because I have so many files open right now. Yes, any doubt so far? Okay, so I think this has opened, became model. This is second order ODE. Now this command, as you can see, solve ODE. This is second order differential equation, homogeneous second order differential equation with certain initial and boundary condition. Okay, but this you have to create in CAS, because this command is not directly applicable here in input bar. So you have to use this CAS part to do this calculation. Okay, so here A and B that I told you, this A and B, this is A is y0, 0, this is value of x, and this is value of y at this point of x. So this is the initial condition 0 y0, and this is 0. Because this is second order differential equation, you need two initial conditions, y dash 0. Okay, so now in GeoGebra, for this point onwards, you are required to play with differential equations where we are having variable coefficients and all. For that, you have to be tricky that how to use the same command solve ODE to solve those differential equations. Okay, so this is y0, which is the initial condition, the number a. If I change the initial condition, then this is y dash 0, right? This is just it. Let me close it and open it again. Okay, by that time, let us come to this decay model. Decay model, where there are certain parameters. So that also follows a differential equation. So those equations also you can draw here. Right? This is like for radioactive decay, where you know what is the decay time, and then you know what is the value of corresponding value of R, so that you can find the solution of the differential equation solve ODE minus RY. So this is about radioactive decay, and when you know the value of T half-life, and then you can calculate the value of R, and then you can draw the corresponding graph. So what will be value at x30, that is f30, what is value at t equal to 50. So you can calculate those values also. Right. Okay, so here you are saying that this is a differential equation, second order differential equation, and for that also you can draw the graph. Now when you change the initial conditions, your graph would change, your slope field would change. Okay. And similarly, you can see the impact of both the initial conditions separately, how y0 and y dash 0 are affecting your solution. So here this is your solution, this is your solution, this is your function g, that is the solution. Just g dash, because we were given g double dash, right? The differential equation was in second order derivative. So when we have found the solution, we are again calculating g dash, because slope field would be created based on the values of derivative only, right? So here you can see how clearly that this is the slope field. Again here also you can change the density of the slope field, the length of the slope field. Okay, and here the initial condition, how the changing of initial condition would affect the same differential equation. Now you can try whether boundary conditions will work here or not. So this is up to you that how you do it with GeoGebra. Okay, so again I come to few basics here. These are like point, where point you can find various types of point. Intersect command is directly available. For intersect, you can see this curve and this curve. So it has shown you that this is the point of intersection, right? Then there is line, line segment, line with the given length, vector, vector from a point. Then for a given line, you can draw a perpendicular line, a parallel line, let us say perpendicular line. So for this perpendicular line, right, this way you can do angle bisector, tangents, polar diameter. Then we are having polygons, different types of polygon, regular, rigid, vector polygon. I think some part of this has already been explained by Professor Rana. So mathematics or graphics are mostly by learning is by doing. So if you practice, you will go to each option, you will do something with that option, then you will learn easily how to use that option. So angle, if you want to find angle between two curves or between two lines, you can use this. Then slope of a line you can find, right? Suppose let us use first the tangent, right? And when you click on tangent, it will select point or a line, then circle, conic or function. So let us first select a point, right? So first I need to draw a point. आपको करना क्या है, that would be told by this only, right? Then for this tangent, then I select this point and this curve. So it is showing you that this is like asymptote, right? So let us choose another some another point or move this point at some another point. Let us move this here, okay? And now I use the same command, tangents, so from this point to this curve. So if I move this point, then see, let us see what happens. If I move this point, you can see, right? So this way you can see what is the tangent at that particular point. Now what is slope of the tangent? So go to this command now, slope, and select the line. It will show you the slope. So it has calculated that m is 0.33. Now let us make it dynamic. You change b and you will see the slope is changing, right? And it is reducing to 0. Now this dynamics you can use to explain some results related to this solution of this second order differential equation. Then there are reflect about a line, reflect about a point. So there are certain commands available here, rotate around a point. Then this is very important. Here you are getting a slider. You can insert your text, you can insert your image, insert your OK button, check box, input box. And here it is mostly for like move graphics view, zoom in, zoom out, show hide object. Shortcuts are available, so not necessary that you go to this part, but just to move the graphics view from this arrow to this move graphics view, these two you need to switch over, right? So when I'm on this arrow, so to move graphics view, I have to click over that. Okay, then only I would do it. So this way you can use GeoGebra to create dynamic diagrams. Yes, this algebra is inside GeoGebra only. So you can you can give command using algebra, or you can create geometry and the algebra will be created automatically, right? So there are both ways to input the things. There are two ways to do the things by input. You can put your input here as a function, as a variable form, so that algebra is created and you will get the corresponding geometrical corresponding graph. Or you can create your graph from here. For example, suppose I create this, let us say this circle. Okay, so I have taken this point and then some radius. Okay, so you see the algebra is automatically created on left hand side. So this is a point B, this is the center, and then this is the equation of the circle. So this is equation of the circle with center at B and radius passing through the point A. And even there are other options also, like you can create a circle with a center and a given radius. So it is asking you for the radius, right? This is looking like an ellipse because right now our x-axis y-axis ratio is not 1:1, it is 1.3. So let us make it 1:1. Now you will see the perfect circles. So perfect geometry, for creating perfect geometry, GeoGebra is a very good software, because here you can create graphics based on the visualization, or you can create graphics based on the algebra. In both ways, you can create your graphics. Yes, any other doubt? Then I will conclude my session. Thank you, sir. Thank you so much, sir. For downloading it, I will share you the link. This is just one click download, and like being exe file, it is very easy to install also. Okay then, so thank you very much for the patient listening, and I conclude my session now, and within 3 minutes we'll start with the valedictory session. Thank you so much.
Hello, excuse me, Ritu ma'am.
Huh?
Ma'am, can you extend the assignment dates on Classroom?
Okay, you submit, because even if I means like it will show me the late submission only. Okay, you would be able to submit late.
Okay, ma'am.
Okay. So within 3 minutes we'll start with our valedictory session.
Ma'am, one question is there.
Yes,
Ritu ma'am,
yes, yes.
now Fatima is asking how can we add GeoGebra in
Sorry,
LaTeX?
I wanted to tell this. I just forgot. Okay. So suppose this is your graphics you have created. So go to file, and this is like export. This is very simple, just like images you export in different formats. So here also you are having this option of export. Okay. So here you can see PNG, EPS, and here this is PGF tags. So PGF tags is basically for LaTeX. So here generate PGF text code. Now this is generated. Select it or copy to clipboard and go to your LaTeX file and paste it. Okay. Here you can select the class also: article class, plain text, content, beamer class, whatever class you want to export. The code will be generated accordingly. Okay. If you want it to be colored, don't check the grayscale. If you want it black and white, you can check the grayscale. So this is very simple to export the graphics you have created to directly to LaTeX. Okay, so any other doubt? I hope you understood.
Yes, ma'am, we understood. Thank you very much for the nice session.
Thank you so much.
So please be interactive when somebody is asking to you that, okay, you understood or not. I was always tired in asking that.
Thank you, Kavita ma'am. Thank you so much for responding. Okay, let us see you all in 2 minutes. Okay.
Yes, right. Yeah. So please see that we have been involving a PhD student to see your chat message and the faculty separately to see and check if you are responding quickly or not. Right? I am not good in seeing the chat message, but I kept a PhD student separately and I asked Sarthak to please check, keep on checking. So you should also be active in responding, right? Somebody is paying hard work, and you also be also responsible, and you all are, right? You have done a very good job sending you all are sending us nicely compiled your assignment. I'm very happy to see your assignments, right? So it is fine if the student is late in submission. There is no problem. The main aim is of this STC is to make you understand there are softwares which you can use and combine in terms of publications, combine in terms of good understanding. So now we will take a 5 minutes break and we'll arrange something online. Ritu ma'am, I now would request to you that you please make some arrangement which we discussed for this validatory. So you see, you can see, I am just pointing out the students that we have a faculty who is connected and want to learn from us. So you see how they are energetic and they are responding us, right? So we should also always be responsible. If somebody is asking, we should always be active. This should be in our character, okay? Okay. So, Ritu ma'am, can you hear us? Okay, so maybe she is taking some break. Okay.
No, no, I'm not taking break. I'm just doing things so that you can
Yes, yes,
all
yes.
see what we have prepared. And,
Yes, yes. Yes, just I wanted to mention that yes, I can understand where our eyes are very now in bad condition to in doing the software data analysis and learning those things. But it is fine. Now you can take the rest and do some eye exercises and then move. Take 1 or 2 days rest. Don't open your laptop, right? So okay, can you make it as a screenshot, ma'am? Sorry, the full screen.
full screen, then
Just slideshow mode. This is fine. So,
I'm not able to see anything.
okay, okay. So, it is fine. Otherwise, you can make it like, okay, it is fine, right? This exercises we made, maybe it is very useful to see each other, right? Because I was not having feeling that to whom I am teaching in this sessions, right? I'm just showing my face to you every day and assuming that you all are there, right, for me to listen. So you just have a feel that we have kept this just a small collect for you to just have a feel that you have those speakers with you, you have those learners with you. We are learning from each other. Okay, I have also learned the GeoGebra with ma'am, right, after my session. So I'll also make some assignment and submit to you, ma'am. Okay. So now, Ritu ma'am, I am handing over to you and you start. Okay.
Yeah, just give me 2 minutes.
Yeah,
Please.
yeah, yes.
Okay, so is my screen visible to all of you?
Yes, yes, ma'am.
Okay, I think now it's better.
Yes.
Okay. So, uh, welcome
Meanwhile,
everyone.
meanwhile,
Yes.
can I take the feedback of the students directly online?
Yes, sir, surely, surely. Let me say few lines for their welcome to the valedictory function.
Okay.
So, so finally we started something good, and everything, whatever starts, comes to an end. So here also we have come to the end of this short-term course, and I hope all of you have enjoyed it and learned a lot. So maybe there may be some lackings there. Maybe we are not able to connect online properly. So you may be having some feedback to share with. So Venkat Ratnam sir, I hand over the session to you to take feedback from the students, please.
Yeah. Good evening to all. So, my dear students, the boys and girls are my ladies and gentlemen. Hello. Please speak. I can call some names here.
Hello, sir.
Hello, sir.
Hidayatullah.
Good evening, sir.
Good afternoon, sir.
Hidayatullah is here. Hidayatullah.
Yes, sir. Yes, sir.
Yes, sir. Okay. How was the workshop now?
Yeah, it's
After
really
end
very
of
good,
the
sir. Very innovative and very interesting.
Okay. Is it a 5 days cricket test match or not? No.
No, sir. It's 5 day, one day international, sir.
It is 1 day or 2020 nowadays? 2020, huh?
Yes, sir.
Okay, fine. So it's really useful. Which
Yes,
background
sir.
you
It's
came
very
from?
useful for my research work also, sir.
Okay. Which
It's very useful,
background?
sir. Yes, sir. I am in electrical
Which
engineering,
background?
sir. Electrical engineering.
Oh, very good, very good. Electrical engineering. So it is very
Yes, sir.
much useful.
Yes, sir.
Okay.
So
And which
Venkat,
university? Ah,
Venkat, He understands your language. That is why he is speaking.
Okay, he is a South Indian or what?
I think so.
Hyderabadi.
Ankita, do you want to say something?
Okay, Pragya.
Yes.
Pragya.
Ankita.
Hello, sir. Hello.
Pragya.
Hello, ma'am.
Hello.
No, this is sir, Venkat sir.
Hello, sir. Good afternoon, sir.
Good afternoon.
My name is Pragya,
Which
and
place
this
you came
session,
from? Which place you came from?
sir, I'm from Rajasthan, Kota.
Okay, Rajasthan Kota. Okay.
Yes,
See,
sir.
how was the workshop?
Sir, this workshop was very interesting and useful. Very useful. Actually, earlier I am from high energy physics experiment, and
Okay.
earlier my seniors make fun of me that I am in high energy experiment and I don't know root. And Kavita ma'am is one of my senior, so she explained uh, very gently and very beautifully,
Okay.
and I learned a lot. And all the sessions of LaTeX and GeoGebra are all very awesome. Actually, today I could not attend all the sessions because of power cut at my place. So,
Okay. Hmm.
but it was very useful.
Okay, don't worry. You will also emerge like Kavita madam. She is also
Yes.
coming from the same place, Kota. Okay.
Oh, yes,
Okay.
sir. Thank you, sir.
Thank you very much. Then any other person give the feedback, then we can go to formal the valedictory function. Is it fine, madam?
Good afternoon, sir.
Please, Sangram.
Yes, sir. Good afternoon, sir. Actually, it is very helpful for me because generally I belong to biotechnology background. So these things are very new for me.
Okay.
And these are interesting, and I learned a lot of things which will very useful for me in future.
Okay. Please practice all these things, root, GeoGebra, LaTeX, and Ritu madam especially present this LaTeX on resume writing also. That is really wonderful. Anybody thought of that actually? Nobody thought. We thought generally this Word document only for the resume and CV.
Yes, sir.
That is the Ritu madam invention to write that in LaTeX actually. So that all and all are really good actually. Is it fine?
Yes.
Yes.
When we were making this brochure and when we are applying for this getting approval, we were confused in that what we are going to get the approval, right? So we were making all the packages in one place so that how we learned from our master to PhD and now what we were lacking in that, how we are we were struggling to get the information. So me and Ritu ma'am has made it like one day we were having tea together and we just made it everything, put it everything, and we were also not knowing how to arrange this. So I think now I am very happy and we'll make again very good collaboration with Ritu ma'am and we'll arrange new things for you people. Okay?
Madam, HOD sir came. HOD.
Actually, Rahul sir, I called. Janani sir is already there, I think.
Janani sir?
I think he was there.
No, ma'am. He left.
Oh, so can you confirm?
Sanjay sir, are you there? Sanjay Bhatter sir?
Yes.
Sanjay Bhatter sir is there? Sanjay Bhatter.
Yes.
Okay, sir.
Then we can start. Sanjay Bhatter sir is there. Then we can start the formal.
It's fine. Yes.
Or any other things?
So yes, let me. Yeah, sure. Thank you, Pragya, for making us realize that okay, we are doing did a great job, right? Please, this is a display of for you. If we miss someone, please don't mind. We will again made it and we will put it and share with you this memento. And if we miss someone or you want me to add someone, please share. We will add it. There is no problem. Okay. If those who missed to send the photos, we will add. But please be more responsible when we ask you to send, because yes. So Venkat, yesterday I asked student to switch on their video for few seconds, and I want to take a picture.
Okay.
So is it possible? Is it possible? I think it should be possible for few seconds, and we can take the digital picture. Is that okay, Ritu ma'am?
Yes, this is a good idea, Kavita.
Yeah. Yes. So
What
how
do
should
do? We switch off our videos?
we will
Switch on.
Yeah, switch on the how I should keep. Sarthak, can you help me to take the picture in horizontal mode?
Ma'am, for that, I think we need to close the presentation first of all.
So Ritu ma'am, please.
So all the
Okay.
so all the participants and persons will be in
Yes.
great view.
Yes. So can you see? I don't think I can see.
No one
We
is visible.
request everyone to please switch on their video. Few seconds.
To switch on your video for few seconds. Very good. So Sarthak, will you be able to manage squeeze?
Ma'am, it's not working.
Ma'am,
For me it is working. Let me check if I can do.
But I cannot see 34 participants at a time.
So let me.
ma'am, speak one by one student name, then they switch on their camera. It is easy.
Can you speak again?
Ma'am, just ask the student by their name, call the student by name, and they turn on their camera and then quickly take the photo and off the camera.
No. We want a common photo. We don't want a single photo. Don't worry. So how can we say that everyone will be in the one canvas? Which full screen? Change layout. Yes, there is a change layout. Yes, I can see complete. There is a change layout I found.
Yes.
Yes, that is fine.
Tiled one. You can use the tiled one.
Tiled one. I use it change layout.
Tiled, the last one. You can see maybe.
Yes, tiled one. I did tiled one, but then
And
still.
Anjana, switch on your camera, and Silpa Mahato, please switch on your camera.
Shilpa, Chitranchi, Sanjay. In which? Yes. Don't worry if you don't looks good, but we have to take. Yes.
Chitranchi Bakshi came or not?
Yes, Chitranchi is just is not sleeping from. So Sanjay sir.
We don't have camera, ma'am. Now.
Okay, camera. It's fine, sir. So Sarthak, are you going to take the picture? Okay. So let me check.
Only 60%, 21.
It's fine. Because. Okay, it's fine.
I think a screenshot may be taken.
Screenshot might be better.
Screenshot will be like, okay, screenshot. So Anis, I cannot see you. Oh yes, you are here. So let me. Anis, are you taking the screenshot?
Yeah, sure, ma'am. I can.
Okay. Can you also, because I don't know if I can.
Let me just configure the because I can only see 16 people at a time.
Yes. It's still 16. Okay. Yes. I don't know how to do it. Okay. Yes, I can also see. Yes.
So I don't have an option to see more than 16. Venkat sir suggested something. Can you please say that again?
That is the tiled one. That is 16 only maximum.
Okay.
Let me. Yes. It is fine. We have taken this, but still we can take one photos of the digital, right? Yes. So at least we can have a feel that
those who are already visible, you can speak their name. They can switch off their video so that others 16.
Yes. So how should I see the names? I'm very poor in doing those things.
Kavita ma'am, I have taken a screenshot, so I can see the names of those who
Okay,
have
so
been part of the
yes,
screenshot.
you just shift all the other 16 and then 16 we will make another collage. Yes.
Okay, so first picture which has been taken includes Ankita,
Okay.
Hidayatullah,
Yes.
Patel Meher, Pragya Nama,
Yes.
Sanjay sir, Vikas Chauhan,
Yes.
Milab,
Mm-hmm.
Mohammad Ashfaq,
Mm-hmm.
Manoj Sharma, Shriyansh, Saroj Chaudhary, Sangram.
Okay.
Okay,
Then
so the next 16, please. Not next 16, next 12. Actually, we'll need 3 pictures.
so please switch on the camera. So you speak the names Kuldeep and Bhavik is not. Yes. Can you? Yes. 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 I can see. So Prabhati, you are walking. So you are taking advantage. We cannot hear him. Maybe his camera is. Yes. Yes. You did
No,
it.
ma'am, actually.
Okay. So you are learning software with walking?
No, not at all walking, madam. I'm actually in the office.
Thank you so much. Thank you so much.
Actually, I must thank you. Very nice program.
Yes, yes, yes. So I cache you from the Facebook. I wanted to share this thing. I cache you all from the different background, from the Facebook and from LinkedIn and from Twitter, wherever I can. So I don't know from where you came. Few of students are already knowing us, but other we don't know. So now we maybe you can make us visible. So Ritu ma'am, you just suggest what is next.
Okay, so few members are still remaining. I think we need a third picture. So let me announce the names once again.
We may do like after 5 minutes, 10 minutes. I think Sunday sir is with us. So
Okay. Yeah, of course.
Okay. So now I invite our HOD Mathematics, Dr. Sanjay Bhatta, to say a few words about this short course.
Okay, ma'am.
Sanjay sir.
Yeah. Thank you. I'm audible. Hello.
Yes, sir. You are audible.
Okay. Good evening, everybody. The member of organizing committee, my dear colleagues, friends, and dear participants. I am sure that this training program has contributed in updating knowledge and skill of the participants, and would also like to advise to put to practice whatever was delivered in this program. Again, I would like to compliment the member of organizing committee in successful organizing this training program. I wish all the participants excellence in their respective field and hope that all of you would write grand success stories. Thank you.
Thank you so much, sir. Thank you for being with us. I think certificates of all the participants are ready and have been already mailed to them. So they may check online that their certificates they have received or not.
Ritu madam, I have a short announcement to make here, if you don't mind.
Yes.
Okay, so I am in the process of sending the certificates. I have sent 12 certificates so far. So in the next 1 hour or so, everyone should be able to get the certificates. If I miss some, please email us and we will send the message or something.
Okay, sir, it's fine. So anybody would like to add something to this workshop? If none, then I invite Venkat sir to propose a vote of thanks.
Okay, thank you, madam. Thank you, Ritu madam. So, on behalf of the organizing committee, may I audible? My dear participants,
yes,
may I audible?
Yes, sir, you are audible.
Okay, fine. So, on behalf of the organizing committee, I take the opportunity to express my gratitude at the end of this workshop More than 40 participants or around 39 participants from various institutes participating in this workshop across the country. This is a huge success in itself. On behalf of the organizing committee, I express my heartfelt thanks to our chief guest, Professor Uday Kumar R. Aragati, Honorable Director, MNIT Jaipur. He gave his support and inspiring words. Thank you, sir, for sharing with us your words of wisdom in the inaugural ceremony. A big thank you to our guest of honor, Professor I.K. Rana, Professor from IIT Bombay, Mumbai, for accepting our invitation for the inaugural function of this online workshop. And he also acknowledged our gratitude, sir, to you for sharing your experience with us and thought a wonderful software tool of GeoGebra. I also express my sincere thanks to Professor Anki Roy, Professor from IIT Indore, for accepting our invitation for the inaugural function of this online workshop and thought us a software tool of Root, which is very important tool used in high energy physics experiments and simulations. I may like to express my sincere thanks to our HODs, the Dr. Rahul Singhal, Head Department of Physics, for giving an excellent description of the Department of Physics, MNIT Jaipur. And Professor Vijay Janani, sir, he is also giving his excellent description about his department. And our beloved Dr. Sanjay Bhattal, sir, who gave an excellent description in the inaugural and as well as now in the validation also he came, sir. We are very much thank you to Sanjay Bhattal, sir. I would like to thank Dr. Kavita Lalwani, convener of this workshop, for the welcome address. And she also taught one of the software tools of the workshop is the Root, which is very much useful in science and technology. She gave hands-on training on Root on all 5 days of the online short-term course. This is also used in the interdisciplinary field, will be useful to COVID-19 data analysis also. I would like to thank Dr. Ritu Madam, one of the coordinator of the workshop. She taught a wonderfully the latex, how the latex is useful in the paper writing, in thesis writing, and especially I am very much happy to see the resume writing also they were using the latex tool. And it's really useful for the master students as well as the PhD students for the different fields. Not only the mathematics, physics, chemistry, all engineering fields also, this latex is very much useful. Thank you, Madam, Ritu Madam, and I would like to thank another speaker and one of the coordinator of this workshop, Dr. Anis Ahmad, for delivering a talk on how to prepare the beautiful, the Beamer presentation by using the TechMaker and related the latex concepts also. He also taught along with Ritu Madam. So thank you, Dr. Anish Ahmed, for your wonderful talks during 5 days. And not only the Anish Ahmed, to all our Kavita Madam, Ritu Madam, and Anish Ahmed to deliver a wonderful talks during this last 5 days. I may also like to express our sincere thanks to all the eminent speakers for accepting our invitation to share your knowledge with the participants of this online workshop. I am also very grateful to TechIP3 for their financial support and encouraging words of TechIP3 coordinator, Dr. Rohit Bahar, Department of EE and MNIT Jaipur. I would like to thank personally Dr. Sardak Singhal, one of the coordinator and the backbone of the workshop from day one of the proposal. The proposal where we discussed that day onwards, the registration and other all important administrative works related to the workshop, along with the convener, Dr. Kavita Lalwani, and also along with the convener, another coordinators, Dr. Ritu Agarwal and Dr. Anis Ahmed. So we are very much thankful to Dr. Sardak Singhal, sir. And
Thank you, sir. Thank you, sir.
We are talking about the participants. The participants are coming from the different background. We observed that one of the participants just we talk about, he is coming from biotechnology, electrical engineering, that mining and civil engineering, mathematics, physics, different fields of the students came and they are showing their interest on this particular top. And after the 5 days also, they have the lot of enthusiasm and the energy. Last but not the least, I thank you all the participants for showing your interest in this workshop. But we are missing you personally, but physically we have no direct class session, only we have the online workshop. So we have eye contact is missing in this regard. So finally we say that this is a very wonderful experience, and it is a wonderful workshop altogether. So all our eminent speakers gave wonderful words, and our administrators also, they supported a lot. Thank you very much, my dear faculty members and my dear participants. That's all.
So I want to add in your vote of thanks. May I add?
Yeah, please.
So I want to thank to you also for this energetic vote of thanks, or also contributing us as a being a coordinator. Right?
Thank you, madam.
Thank you.
Okay, thank you everyone. Thank you so much for being part of this workshop. And it feels like we are leaving a family after these 5 days. So maybe we are not going to forget each other. So we will be keeping in touch. All the best to all of you. Thank you so much, everyone. Your certificates will be mailed to you, and this collage also. Okay, thank you.
Thank you very much. Yes. Please be connected and continue using the software and send us the feedback. Okay, if you need some help, we will help. We will be happy to help you. Okay, see you. Bye bye, Venkat sir. Bye bye all. Bye bye, Sarthak, Ritu ma'am.
Bye bye.
Bye bye. Bye bye.
Okay, bye, Sabir.
Bye bye. Bye bye.
Thank you, Sabir sir. Thank you so much for being
Yes.
here.
Yes. Bye.
Thank you, Sanjay sir.